Now, before we begin the tutorial, if you want to follow along exactly how I'm doing with the assets that I'm using, make sure to use the link in the description. You'll get the assets and the source code immediately. Just in case you get stuck, you'll be able to use the assets. Now, let's get right into the tutorial. Now, we're about to build a big 3D platformer. So the first thing we're going to do is simply just add the ground. That's all we need to do, add the ground. So let's add a new object. And since we're doing a full tutorial, we're not going to be using cubes. We're going to be actually using 3D models, which is what you would be using if you made your own game. You wouldn't be using flat cubes unless that's the style you're going for. So let's go and add a 3D model. Now, when it comes to the 3D model, once again, you can use any model you like. But I'm going to go into my files and choose a grass block asset that I have. So I'm going to go into my downloads, go into the assets, and we're simply going to choose this grass block. And with this grass block, now we have our ground. Now, when it comes to the ground, of course, you want to name your object accordingly. So we're going to name it ground because we're going to have to reference this in the events. And you can choose whether or not you want to add lighting to your game. Normally, you do want to have lighting, but if you don't, you can just get rid of shadow casting and shadow receiving. And also, right now, if we have our ground object, if we add a player to the scene right now, the player will fall through the ground. And that's because this ground has no behaviors. So it's just a regular picture on the scene. So what we're going to do is add a physics 3D behavior so that physics objects can interact with the ground. So I'm going to add a new behavior. And then when it comes to the behavior, what you want to do is type in physics and physics 3D. And what will pop up is the 3D physics engine. Once you have the 3D physics engine, the important thing here, because you don't have to worry about this, I already have a tutorial on 3D physics, but the important thing for ground is that you want to set the type to static, because a static object will not move. A dynamic object will move like a regular object in real life, and a kinematic object will not move unless events act on the object. But when it comes to static, no matter what events you use, a static object can never be moved. And just in case it can never move, you really don't have to do this, but I just like to add fixed rotation. It just makes me feel extra safe, even though it doesn't do anything. So once you have this, what you want to do is hit apply, and then what you can do is drag the ground onto the scene. And when you drag it onto the scene, you'll see it in a 2D view here, and you can set the size to being larger. And so I'm going to make it a decently sized platform that we can stand on because we're going to be adding enemies later. So I'm just going to stretch it out. And also something I recommend that you do for your game, especially when it comes to testing, is to set the Z order or the Z value, because it's not Z order. Set the Z value of your 3D ground to be something that's lower than 0. So I'm going to set this as -200. And what this would do is make the ground lower down. And this makes it so when you add new objects, like if I were to add another ground, you don't have to keep manually adjusting the Z value of those objects so it can show over it. So I'm going to delete this ground. And also what you can do is click into the 3D view up top, because GDevelop now has a 3D editor if you're watching this. And you can look at this in a 3D view. And I'm assuming you already know how to navigate the 3D editor, but I'm using my scroll wheel to rotate. And I can also use my right click to rotate around. And I can use the arrow keys to move left to right. Just showing you this just in case you're new to the 3D editor. So, and also if you want to move left and right faster, you can use shift. You can also move up and down. You can use the arrow keys to move and shift to move faster. That's just in case you've never used a 3D editor before. So now we have the ground object in our game. Now it's time to make the first major part of this platformer game, and that is the player. Now the funny thing is that even though the player is one of the most major parts of a platformer, for this platformer, the player is actually going to be one of the easiest parts, and the player is not going to use any events. We're going to be using strictly behaviors and extensions for our player. That's how easy it's going to be. Now, it won't be completely easy. There is a little bit of explaining to do, but it's definitely not going to be that hard. Now, of course, our player is also going to be animated. It's going to have animations, and it's going to be a 3D model. So it's going to add an object, and you can already guess we're going to be using a 3D model. Now, of course, you can name this player, name this whatever you want to, preferably player, and we're going to import our main character object. Once again, you can use the assets for that. So I'm going to go into files from my device. I'm simply going to double click into main character. That's what it'll be called if you've downloaded the assets. Now, when you have the main character, once again, you have all of the regular settings for the main character. and we're going to add animations, but not just yet. Now, since this is going to be a fully animated player, whenever you're doing a fully animated 3D player, the first behavior you want to do is not going to be a 3D physics object. The first behavior you want to add is going to be a 3D physics animator. So what I'm going to do is type in physics character, and it should show up eventually 3D physics character animator. That's what it'll be called. And the description right here says change the animation of 3D physics character automatically. So we'll click into that. And the reason why I had you click into that first is because when you add a 3D physics character animator, GDevelop is smart and will automatically add all of the behaviors that it needs to function properly. So when you do this, you'll have a physics character that is dynamic, and you'll have the physics character 3D. So you have the physics 3D extension / behavior, and you'll also have physics character 3D. Once again, I explain how to use this in my physics character 3D platform, so we're not going to waste time going into the depths of this, but most of this is self-explanatory anyway. But what we want to focus on is the physics character 3D animator. And there's a few things when it comes to the physics character 3D animator. We have the rotation speed, which is not too important because we haven't even added our camera yet. But what's really important is the animation names, because what it does is it checks your animations that are in your properties, it checks their names, and then the behavior does all of the animating for you without using events. It will automatically detect if you're idling, if you're jumping, running, or falling. Now, we don't have to worry about falling because our player model that we have doesn't even have a falling animation. It'll stay the same as the jump, so we don't have to worry about falling. Now, in order to actually make this work, we need to add animations to our player. So let's go back into the properties and let's add a new animation. And I'm going to add 3 animations because we're going to only be using 3 main animations. Now, we have our idle animation. So animation 0, we're going to click into the drop down menu, and you want to click into idle. And for animation 1, we're going to have this be running. So you want to go into your scroll down menu, or drop down menu, and then click into run. And for the last one, we're going to have this as jump. So just find jump on your player, and that's why we're using assets to make it easier. Once again, if you're using your own asset, it has to be a GLB file that already has animations ingrained into the model. And that's more of a Blender tutorial. You'll have to look up a Blender tutorial to do that yourself. But you have to have the animations ingrained into the GLB file in order for this to work with the drop down menus in GDevelop. Now, let's get back into it. We want to set the idle as being a loop, so it'll keep playing continuously and not play once. The running will also be a loop, but the jump will not be a loop. Now, if we go back into the behavior, you'll see that when it comes to animation names, it's referencing the name here. So it says idle, jump, and run. But that's not referencing these right here. It's referencing the animation name that says optional animation name. That's what it's referencing. So in order for this behavior to work, we have to name the animation. It cannot be unnamed or it will not work. So we're going to name our first one idle. We're going to name our second one run, of course. And then the last one is going to be jump. And if we go back into our behaviors, just double check to make sure that this fits. And if you want to, you could also change the text, but the default is completely fine here. Don't worry about fall. We don't have an animation for that. So we're going to hit apply, and now we're going to preview to see if it's working. Now when you preview, first of all, you won't see that it's working because there's no player. But let's drag our player into the scene first, and you'll see that we're already over the ground right now. We can drag our player onto the scene, and let's go ahead and preview. Now when we preview, we will see the player fall, and it will be in its idle animation. But currently we can't move because we haven't added the behavior to make our player move. So no matter what we press, we will not be able to move. But we can see that the idle animation is working. So let's go ahead and add our movement behavior. So let's double click into our player, and let's go into our behaviors. And for the behavior, we're going to add something that is called platformer 3D keyboard mapper. So I'm going to add a behavior. It's going to be platformer 3D keyboard mapper. And it's good. Make sure you put the platformer 3D keyboard mapper and not the gamepad mapper, because the gamepad mapper is for a controller. So put 3D platformer keyboard mapper, and once you click into that, it'll give you the keys for your gameplay. Now, This can be changed to whatever you want. This is very self-explanatory because this is just WASD layout featuring space. So you can use the drop-down menu and you can access any key on your keyboard in order to change this, and we don't have to use events for this. So I'm going to hit apply, and let's preview this one more time. And now when I preview, if I press D, I'll move to the right, and you see that everything is working completely fine. We can move around in all 8 directions. We can even move diagonally, and everything is working completely fine. And you can see that the animations for our player are also playing automatically without events. So everything is completely fine right now. So now that we have this, we're going to add a simple camera first, and then we're going to add an advanced camera. So what we're going to do here is double click into our player. Let's go into behaviors, and let's add one more behavior. We're going to add another one later. But we have a third person camera. And this is a simple camera that if you wanted to, you could leave it at this simple camera and not do the advanced one that we're about to do soon. But this is a more advanced tutorial, so we don't want a camera this limited. I'm going to show you why we don't want a camera this limited. So once again, I have a tutorial that also explains this, so we're not going to go too deep into it. The default values are fine, except for camera distance. I like that to be like 700. But the default values will work here. So let's hit preview. And now that we have a third person camera attached to the player, you'll see now we're looking at the player from a third person view. And you see that it can rotate with it. If you don't like this feature, because I personally hate the camera trying to rotate with the player, I really don't like it. So I'm going to double click into our player, go into behaviors, and we're going to get rid of automatically rotate the camera with the object. Now, just a note on this, when it comes to automatically rotating the camera with the object, if you don't want to use the mouse for your object, then you should keep this checked. This is good for if you don't want to use for the mouse. But for really good 3D platformers, you're going to want to use the mouse for freer movement, which we're about to do soon. So you want to leave this unchecked so that it won't move with the object. So now that we have this, if we move around now, you see that the camera will follow us, but it will no longer rotate. And the problem with this is that even though we fixed the really annoying rotation that the extension automatically does, we can't really see behind us anymore, and we can't see, like, if I want to look to the left in that direction, I still can't see any object in that direction, which leaves us a lot of blind spots and makes going backwards terrible in the game. So the next thing we're about to do is add the advanced camera using a mouse. Now it's time to add the advanced camera, which is using a mouse, which is the preferable way to add a 3D camera for a platformer. Now I'm about to perform some magic here, and when I do my magic, I'm about to paste an extension that's not in GDevelop natively, which I'm not exactly sure why it's not. Now I'm pasting an extension called Platformer Camera 3D, and you can access this using the source code that's in the description. But I got this from GDevelop's example project, so the credit goes out to GDevelop for that. But GDevelop's example project has this Platformer Camera 3D extension that can be used for a mouse-controlled camera without events. Now, I'm not sure why this isn't public, but once again, you can use the source code if you want to paste that in. So, now that we have that behavior, all we want to do is add it to the player. So we're going to double-click, and we're going to go into behaviors. Let's add a new behavior. And what it's going to be called, I kind of forgot the name that quick. Let's put third. And the funny part is I mistyped that, but it says 3D platformer third instead of third person. So they have a typo here. Maybe that's not why it's in native GDevelop. But what we want to do is click into it. And once you have platformer camera 3D, you'll have a few settings. And they're mostly the same as these right here. They're related to that. Once again, I explained that in a previous video, so we're not going to worry about it too much. But the default settings right here are fine. So we're not going to do any editing here. So let's hit apply. But if we preview, since it's controlled by the mouse, you'll see that we can't move it just yet. We can move around and things will be exactly the same, but we can't move it. And the reason why we can't move it is because the mouse cursor that you can see right here, in order for this behavior to work, the mouse cursor has to be locked in. So how do we actually lock in the mouse cursor? Now, if you're familiar with developing 3D games in GDevelop, you'll know that we need an extension called mouse pointer lock in order to lock the mouse cursor in the game. So we're going to go back to the top left and add another extension. And this is going to be called mouse pointer lock. Once again, a common extension made by Pandaco and D8H. And we're going to install this into the project. Now, it's very easy to lock a mouse cursor in a game, but we are going to need to use a few events. So, I already have it set up here, but I'm going to delete it just for the sake of the tutorial. So now I get ahead of myself here. So we're going to add a new event. And all you have to do is that when the mouse cursor is clicked and the game has not locked in the cursor, then you want to lock the cursor into the game. It's super easy to do, and you just saw the events of how simple. So let's add a new condition, and we're going to go into other conditions. And the first thing we want to do is check if the mouse cursor has been clicked, or the mouse button has been clicked. So you want to put mouse button pressed or held, and we're going to check if the left key has been clicked. And also we want to check if the mouse cursor has not already been locked, so we don't have to have repetitive events running in the background. So let's add a condition. Let's go into other conditions, mouse pointer lock, and we can check if the pointer is not locked. And you see right here, it says if the pointer is locked. All we have to do is invert the condition to check if it's not locked. So we'll do the opposite. And now for the action, what we want to do is lock in the mouse cursor. So we're going to add an action, other actions once again, mouse pointer lock, and all you have to do is request pointer lock. And as it says here, it's going to lock the mouse pointer and it's going to hide it. Let's click OK and click preview. And now that we have this, what you want to do is click into the game first. And when you move around the mouse, immediately you'll be able to see that you have full 3D control. And since we're using the WASD layout, once again, this is much better and much less annoying than the camera automatically rotating every time we move our player. That's not a good thing to have, so that's why we're adding this advanced camera. And that's about it for the third-person camera with the mouse. One thing I do want to mention, if you are somehow still confused on the extension, what you want to do in your source code is right-click into Platformer Camera 3D in the extension tab. It'll already be there. Just right-click it and then copy it, and then go into your project that you're making and then paste it in the extension tab. But that's how you add the advanced camera for the player. Now, before we get into making coins and collectibles, one thing that we need to handle is that the possibility that you may have had an error. Because when you first make your project and you first load up the scene, it should look like this at all times. But it may not show here. But sometimes when you load the scene and preview it, sometimes an error does pop up. Like I said, it's not showing up here, but I know some people are going to run into an error. And if you do run into an error, there's no problem because I ran into the same thing while I was building this project for the very first time. In order to fix this weird error that you might get when you load your scene, what you want to do is go into the top left and then go into Platformer Camera 3D. And the error comes from sometimes when you load the event, will load the extension, it will try to load up extensions that don't exist in your game. And what I mean is that what I just did is I clicked into Platformer Camera 3D and I checked the settings of it. So once again, just to show you again, I went to the top left, went to the three buttons. Well, actually I didn't use three buttons, just click it. Just click it. And once you click it, you'll see that it's accessing different extensions in its own code that makes it work. And all of the events / code that makes it work. So you have gamepads that is accessing, and then you have sprite multi-touch joystick. So in order for this to actually work properly and never return an error, all you have to do is add these extensions to your game, and you won't have these errors at any time. So what we're going to do is go back into our untitled scene. Let's go to the top left, go into extensions, and we already have gamepads at the top, so we're going to click into that, and we're going to install this into the project. And when you install gamepads, when you click back into Platformer Camera 3D, you'll see that you'll have no more errors that are related to the gamepad behavior / extension. But also another thing that we need to handle is the sprite multi-touch joystick. And that's because, like I said, this camera extension can handle keyboard, it can handle gamepads, and I believe it can also even handle mobile. Because GDevelop made this and they made it very flexible. So we're going to go back into our scene events, go to the top left, add one more extension, and this is going to be sprite multi-touch joystick. And once you put sprite multi, you'll see that multi-touch joystick and buttons pops up, and you can install this into the project, close it out, and then check back on platformer camera 3D to make sure that there are no red squiggly lines. That means that it's trying to access something that's not there. And once you do this, there will be no way that you get an error. Like I said, some viewers may see the error that I'm talking about, some viewers may not, but make sure you do that step whether you see the error or not, because sometimes randomly it'll just pop up on you, and that's the only way to fix it, because your game is trying to access extensions that are not there. Now back into the collectibles. We're going to create a collectible coin, and all this coin is going to be just like in most 3D platformers. We're going to have it on scene, and when you touch it, it will delete itself. And also it will be constantly rotating, because most of the time coins don't stay static in 3D games. So this is very easy to add. This is a very basic feature. So let's go ahead and add a new object. And this object is going to be a 3D model, of course. We're going to name this object coin. And we're going to use our coin from our files. Once again, I recommend you get the files, but you can also use any file you want because it's just a simple coin. So once you have the coin, we're going to hit apply. And we're going to drag the coin onto the scene. Now when you drag it onto the scene, is going to be pretty big, and to resize it, you probably already know how to do it, but if you want to resize it neatly, make sure that keep ratio is on, and then you can scroll over with height or depth, and then you can click it and hold it, and if you scroll to the left, we'll move your mouse to the left, it'll get smaller, move your mouse to the right, it'll get bigger. So we're going to make this much smaller, and now we're going to select our coin and drag it onto the grass so we can see it. Now, we haven't added any events to make it rotate, so let's go ahead and do that. Let's go into our events, add a new event, and just before we do anything, just to keep our events organized, because we're going to be adding a lot of events, let's go ahead and create a new event group by right-clicking, add, and then we're going to make a new event group. We're going to call this collectible logic. This will hold all of our logic for our coin, and we're going to drag our event under the event group. And once we have that, remember what we're trying to do. What we're trying to do is make a coin consistently and constantly rotate at all times. And whenever you want something to always happen, that means there's going to be no condition. So the condition can stay blank. And remember, we want this to rotate. So we're going to add an action, and we're going to click into coin. And you see that we already have things for this right here. We have rotate. And this for 3D objects is rotation around the z-axis. So this should work with rotate, but you can also use angle, which I like to use. And angle is the same thing as rotating. So to make something rotate using angle, all you have to do is add to the angle, because that's all that rotating is. Rotating just simply changes the angle of an object. We're going to add like 90 degrees. So it will rotate 90 degrees constantly. And you'll see that if we do this, it starts flipping really fast. So we're going to X out the scene. It looks pretty funny. And I'm going to put it at 35 and see if that looks a little bit better. And you just want to set it to a value that looks normal. So you see that even this is pretty fast. And I'm going to set it to like maybe 5. Like you can just play around with different values until you get something that looks semi-normal. And 5 looks pretty good. Just remember, you can use either rotate or you can use adding angle to your coin. So now we have it constantly rotating, but we want to make it so when we jump on the coin actually deletes itself. That's how collectibles work. So we're going to once again X out our scene. Now, one important thing to note is that when you're dealing with two 3D objects, we have one 3D object, which is the player. And the player it has a physics 3D behavior to it. And when it comes to physics objects that have the physics 3D behavior, if we look in our conditions, they have their own collision for physics 3D. But this is supposed to be used when you have two objects that both have a physics behavior. In our case, we don't have a physics behavior on our coin, and we don't want to add it. Because in some objects, you won't want a physics behavior to be part of that object. It's not necessary. So when you have this type of mismatch, there's an extension that can help you with 3D collision when you have a mismatch between objects that are not physics. And we're going to go into our top left. We're going to add a new extension. And this is simply called 3D collision. And every time you make a 3D game, I recommend that you get 3D collision because it works perfectly. It's still experimental, but it works perfectly fine. I've never had any problems with it. Made by DAH, and I'm not going to pronounce that right now. Tlunvaki Productions. That's the best I can do right now. But we're going to install into the project, and once you have this, now you can use the condition just like you would any other condition. So we're going to double click into our event. Well, this is not the right one right here. This is for changing the angle. We're going to add a new event. So I'm going to add a new event below this one. And remember, what we want to happen is that if the player is in collision with the coin, then we want to delete the coin. So if that's going to be the condition, so we're going to check if the player is in collision. Now you want to type in collision, and it's important is that you're going to see all of these collisions. Do not click this one. This is for 2D objects. And once again, collision right here, this is for 2 objects that have physics 3D. You want to click the one that has these 2 dotted line squares. That's the one that you want to click because that's related to the behavior. So it's going to ask you what collision you're checking. So we're checking if the player right here is in collision with the coin. And that's all we want to have. We're going to click OK. And we're going to add an action. And the action is going to be to delete the coin. That's all we want to do. It's very easy. Delete the object. Click OK. And now when we preview it, it should work perfectly fine. So if we jump into the coin, you see that it deletes itself. And once again, you can even add sound effects if you want. You can add anything to happen when you collect this coin, but that's how coin collectible logic works. Now the next thing we want to do is add a moving platform. So we're getting into more of the fun stuff of what makes an advanced 3D platformer actually advanced. And moving platforms are not too hard to do. They're actually quite easy. It's going to use a very, well, I wouldn't say very simple. It's actually quite mathematical formula, but you don't have to understand everything about it in order to make it work. Now, when it comes to a moving platform, we want the moving platform to be able to move back and forth, either in the X direction or the Y direction, or even the Z direction. So moving platforms are not too hard. We're going to break it down step by step. So let's first start with, of course, creating the object. That's what we're always going to start with. So we're going to add a new object, and this is going to be another 3D model, and we're just going to reuse the ground. We're actually just going to reuse the ground. So let's choose a file from our device, and I'm going to just choose this ground right here, cube grass. And once we have this, we're going to hit apply, and we're going to place it onto the scene. Well, actually, let's rename it first. I'm going to quickly rename this to moving platform. Like having underscores, I'm kind of specific about how I like to have my stuff. So we have moving platform with an underscore just to make it special. So now we have this moving platform. We're going to set a Z position as a little bit lower, actually the same as our ground, which is -200, so our player can actually jump on it. And what we want to happen is that we want our moving platform to move back and forth on the x-axis. That's what we're going to have it doing, back and forth on the x-axis. Now, for the formula that we're going to use, we're going to need a start position of our moving platform. And this is going to make sense in a little bit, but we're going to create the variable first, and we're going to do the formula later so you can understand it. Now, let's double click into our moving platform. And each moving platform, so they can be independent of each other, you need to make this an object variable instead of a scene variable. So let's click into our moving platform first, go into the variables tab, and add a new variable. And this variable is going to be a number, and we're going to call it start x. And this is going to store the starting position of our moving platform, because we're going to need the start position for our formula later that we're going to get deeper into. So you can name this start x, and we're going to hit apply. Let's go back into our events. Let's close this out for the coin, create a new event, and we're going to be doing this a lot, so go ahead and get used to it. Whenever we're making a new feature, we're going to make an event group so our events don't get cluttered. So we're going to create a new event group, and we're going to call this moving platform. This is going to handle the events related to our moving platform. So I'm going to drag this event under here once again. And the first thing we're going to do is at the beginning of the scene, we're going to change the variable start x to the x position of our moving platform. So basically, if I drag it up here, you see that our x position of our moving platform is 1471. That's the x position. So when the game starts, it's going to store that for the formula. And if I had another moving platform and I duplicated it, and it was right here, the x position of this moving platform, start x, the variable would be 1725. And these would move independently of each other, and they wouldn't move exactly the same because they have different starting x positions. So they're not going to start at the same point. This allows them to be independent of each other. So now that we know why we have start x, let's actually program the logic for that. So we want this to happen once at the beginning of the scene to all of the moving platforms. So what we're going to do is add a condition, go into other conditions, and we want this to happen at the beginning of the scene. So we're going to click to scene and at the beginning of the scene. So just when the scene starts, this will be set. The start x of each platform will be set. So let's add a new action. And we want to change the variable start x to equal the x position of our moving platform. So let's go into our moving platform because we're trying to access a variable that's part of it. We're going to type in variable, and we're going to change the object variable value start x. That's what we want to change. And we're going to set it equal to moving platform. We want to access the x position of it. So we're going to set it to moving platform dot x. Then we're going to put parentheses. So just as a recap of these events, at the beginning of the scene, we're going to change start x to be equal to the x position of the moving platform, like I just explained earlier. This platform, start x, would be equal to 1502. Well, that's not the way to say it, 1502. So if we preview, of course, nothing's going to move because we didn't make the formula. But just know that start x is currently 1502, if you really need to know that. Now, of course, you don't care about start x right now. Let's get into actually making the moving platform move. So let's add a new event under. So I'm going to click this and put Shift A to do this quickly. And we're going to be using a formula. We're not going to be using an extension for this. And it's important that we use formulas because formulas help a lot with moving physics objects. Because that's another thing that we have to set up. It needs to be a physics object. So before we do that, because it won't work properly if we don't do that, let's go back to our scene and let's double click into our moving platform. Go into behaviors and add a new behavior. It needs to be a physics 3D object or this formula is not going to be working properly. So we're going to put physics 3D and it's going to use the 3D physics engine. Now, we're not going to have it be dynamic or static. It's going to be kinematic. And remember, kinematic objects do not move unless events start to change them. So since we're going to be using events, it will move. But if we don't use events, it will never move. We're going to set it to fixed rotation so it can't rotate. And we don't need to change anything else here. So we're going to go ahead and hit apply. And now let's actually make our formula. So the formula is going to be changing the x position using a sine wave. Now, if you don't know what a sine wave is, and when it comes to values and how this logic is even going to work, a sine wave, if you look at my mouse, it moves in a curve. It moves up and down, up and down, up and down in a curve. If you've did higher level math, you've probably already heard of this, even if you haven't did it. So a sine wave, it moves up and down. So that's what allows the value when it comes to a moving platform to move back and forth. Because as you move along a sine wave, the value goes up and down smoothly. It goes up and down. So that's why we're going to be using a sine wave here. So let's get out of the mathematics here and let's actually make the formula. So let's add an action here. And what we want to do is change the x position of our moving platform. So I'm going to click into the moving platform, going to click x position, and we want to set this equal to, now here is the formula. And I'm going to make the formula, and then I'm going to explain the formula. So just follow along with me for a second. So the first thing we're going to put, is moving platform. We're going to put moving platform dot, we're going to put dot variable, and we're going to put parentheses. I'm going to put I'm going to put start x, and I'm going to put plus 200 times sine, this for the sine wave, and then time from start. I'm going to explain this right after we get done making this. It's better to just do the explanation after, because if I don't, you'll probably be extremely confused. And I'm going to put times 1. So this looks like a bunch of nonsense right now. So what is this actually doing? So we have moving platform variable start x. So we're accessing start x, moving platform start x. So we're adding start x. We're adding with start x 200. So what do I mean by this? Let's handle the first part. This first part controls the distance of how far your moving platform moves left and right. And this second part, this controls the speed. We're using time from start is because this is a value that constantly gets higher. And as you move higher on the sine wave, it just keeps going up and down as you can continue to move higher. So that's why the platform goes back and forth. So just remember, the most important thing is that if you want to edit the speed, you would change this value of 1 to something higher or something lower. And if you want to edit how long it moved, like the distance that it traveled, you would simply edit 200 to be something higher. So now let's see this in action. Let's preview this. And we preview. See that it's moving back and forth. And it looks like it's moving up and down on the y-axis, but it's actually moving on the x-axis because as we move it across on the x, it's going to be kind of looking like it's moving up. So once again, when it comes to this formula, the sign part is not too important. This is really not too important. That's just mathematical stuff. What you need to know is that if you want to change how the distance of how it moves, the total distance, make this higher. And if you want to change the speed, make this higher or lower. So once again, I'm going to preview this, and you'll see that it moves back and forth properly and smoothly. And this is not only for moving platforms, we're going to actually use some similar events for our enemies that move back and forth. And we can also stand on this platform. Now it's kind of small, so I just did a parkour fail. So let's make it bigger so we can stand on it better. And if we preview this, we're just going to simply stand on the platform. So I stood on the platform and I fell off because I'm bad at parkour. But I do want to showcase that you will stick onto the platform when you're done. So once I stand on it, you'll stick on the platform. And this naturally happens because of GDevelop's physics system. So we don't have to make any extra events to make the player stick onto the platform, because that could lead to a whole nother set of complications. Now, that is the basic setup for a moving platform. One thing I do want to note is that if you want to do this in a different direction, all you have to do is do similar events, but instead of start X, this will simply be start Y. And you would be setting this to moving platform.y. And you would set this, you can already see what I'm talking about here. This would simply just be start Y. And you would be changing the Y position of moving platform to be this formula. Everything is exactly the same except for this is start Y. And this is the exact same thing for the Z axis as well. So this is a very flexible formula. And if you want to make different platforms in different directions, make sure to refer back to this part. And just make sure to change these parts accordingly. Change start X to start Y. Change the X position to change the Y position, so on and so forth. And that's how you do a basic moving platform. Now it's time to add the player death logic and checkpoint logic. And checkpoint logic is going to be really good because whenever you have a long platformer game like this, where you're going to be designing big levels, you're more than likely going to want to have checkpoints. And of course, there's going to need to be a way for the player to die. Now, when it comes to making player death for almost any game, the first thing you want to do is set up a variable that checks whether or not the player is dead. And the reason why you want to do this is because all you have to do is set that variable to true. And then when the variable is set to true, you can trigger a certain set of events. So it will be based off the variable being set to true instead of you having to do if the player is in collision with this, if the player is in collision with that. You don't have to keep copy and pasting a big set of events for what you want to happen after the player dies. So let's get into it. We're going to make this a scene variable because we want this to be able to be accessed at all times in the scene. So let's go into our top left and let's go into our scenes. Click the 3 dots beside your scene, and then you want to open the scene variables, edit the scene variables, that is. So let's add a new variable. And this is going to be a Boolean because it's only going to be true or false. So we're going to set this to a Boolean. And we're going to name this P dead. This is just short for player dead. And by default, it's going to be equal to false, because if it's true by default, we're going to be dead as soon as the scene starts. Now, once again, we're going to create a new event group. I'm not going to really say much through this because we already know what we're doing right now. Name this something accordingly, because this is what this is going to be handling: player death and checkpoints. And we're going to drag our first event under here. Now, what we're going to be doing right here is that when the player dies, for the basic death anyway, when the player dies, we're going to delete the player, we're going to wait 2 seconds, and then we're going to restart the scene. This is going to be if the player hasn't touched a checkpoint. But since we're going to be using restarting the scene as our way of resetting, we're going to make it so at the beginning of the scene, player dead is set to false. Because we don't do this, when our scene resets, we'll just immediately die. So, we're going to make a condition, and the condition is going to be at the beginning of the scene. So we're going to click into our scene at the beginning and click OK. And what we want to do is right at the beginning, we want to set P dead as equal to false, so that we're not dead as soon as the game starts, no matter what. So we're going to go into other actions. Since we're accessing a scene variable, click into variables, change variable value, and set it to true. Well, not true, set it to false. My brain did it naturally better than what I was saying. So at the beginning of the scene, we're changing P dead to be set to false. So now that we have that, Shift A to create a new event below. Now we're going to have the logic for actually killing the player. But before we do this, we need to actually create an object that will kill the player. So we're going to simply create a static little cube that will kill the player once we touch it. So we're going to create a new object. It's going to be a 3D box. Since it's going to be something static, we don't need a model for it. We're going to call this kill box. It doesn't even matter what it is. This is just a simple test object. And I recommend that you use this for falling. You can make it invisible and then use it for falling. So I'm going to create a face with piscal. You can make it any color you want. I'm going to make it like this pinkish color. You can fill it up and save. And then all you have to do is copy one face, and then you can paste it into the rest of the boxes right here. And it will have the exact same sprite without you having to keep clicking to project resources. This is a much faster way of doing it. Now once we have this set up, what we want to do now is set up the events now, since we have an object. But actually, before we do that, we want to drag this, of course. So we're going to drag this onto our scene, and we can actually keep it at this size. I guess it's pretty fine. Let's preview the scene to see where it's at. That's actually in reach. This is in reach. So we want what to happen is that when we jump into this, we die. That's what we want to happen. So let's go back into our events. And this is simple logic. If the player is in collision with kill box, then we set P dead to true. So let's add a condition, and we're going to check if the player is in collision. And remember, we're going to be using the ones with the dotted lines because kill box is not a physics 3D object. So we want to check if it's in collision with kill box. And we only want to check this once. It's going to be a trigger once. We don't want to keep setting P dead to true, or the events that we set after the player dies could possibly continue to keep playing. It's a possibility. So we're going to use trigger once after this. Other conditions, let's go into trigger once. Let's click OK, trigger once. And once we have that, what we want to do, of course, is set P dead is equal to true. So actually we can just copy it from here. So I'm going to click this action, copy, and then paste it. And we're going to click set to false and put it as set to true. So now if player is in collision with kill box, set P dead to true. Now even though this sounds good in theory, right now this will do nothing, because when P dead is equal to true, we have no events that actually make it do anything. So let's add a new event under this and start setting up some events. Now, remember what we said earlier. We want to happen when P dead is true, we delete the player, wait 2 seconds, and then we're going to restart the scene. So this is pretty easy to do. So first we want to check if P dead is true. So let's add a condition. Other conditions, go into variables. You probably know this by now. P dead, and we want to check if it's equal to true. And we want to put this as a trigger once to also remove the possibility that any duplicate actions could keep playing. because it's going to check this only once when it's true. And once it's true, we want to delete the player and then wait 2 seconds. So let's add an action, click into our player, and then we're going to go ahead and delete it. And once we delete it, we're also going to wait 2 seconds. So let's add another action, and let's go into our timer section. So we're going to click into timers and time, wait X seconds, and we're going to wait about 2 seconds. So once we have this set up, you wouldn't want to just wait 2 seconds and then put directly under this, change the scene to level 1, which would restart it. And the reason why we're not going to do that, because that's not really flexible for setting up when we have a checkpoint. We need to make way for having that checkpoint. So we're going to actually add a sub event. And what sub events can do is that they can give you different possibilities depending on other variables. Because later we're going to have a variable that checks whether or not we've touched a flag. So we can have a sub condition that plays certain events if the player has touched the flag or the checkpoint, and then we can have another set of events that only are played if the player has not touched the checkpoint. But don't worry about too much, it'll make more sense when we get to it. Now, since we don't have any checkpoint variables, all we have to do is that we just change the scene to level 1. That's all we have to do. That'll restart the scene. So let's add an action. Let's go into our other actions, and let's go into our scene, and we're going to change the scene. And of course, it's called untitled scene. You can also name this whenever you want to make it something better. We're going to click OK. Now let's go ahead and preview. So what should happen is that when we touch the kill box, pdet will be set to true. And once it checks that it's true, it's going to delete the player, wait 2 seconds, and then our scene will be loaded up. So it's going to take a little bit of time to load. So I'm just going to give it a little bit more time. So once we have this, we jump to the box. You see that we die. We wait 2 seconds, and then the scene completely restarts. And the good thing is that you're back alive when it starts, because we have at the beginning of the scene, we're setting pdet to false so we don't die as soon as we get revived. And that is how you set up the basic death logic for the player. Now it's time to create the player death logic with a checkpoint added. Now what we're going to do with the checkpoint is that when we have the checkpoint, the player is going to touch the checkpoint object, and then we're going to save the position of the checkpoint. And we're going to save that inside of a variable, and then once the player dies, we'll spawn the player back at that X position, which was just saved into 3 different variables, which we'll make later. And this is a flexible system that will work with an infinite amount of checkpoints. So let's get into it. The first thing we need to do is create, of course, the object itself. We're always going to start by creating the object. So we're going to keep this kill box. I'm going to just put it over here for now. And we're going to create a new object in our scene. Once again, there's going to be a 3D model since we're working with a 3D game. We really want to practice using models. And we're going to name this object checkpoint. Now, we're going to import our model. Once again, I'm going to use our assets that we have. I'm going to double click into the flag. So let's double click into here, and we have flag.glb. So this is completely fine. We have our flag here. Everything here is completely fine. Now we do want to add some object variables. Well, not some object variables, but we do want to add some variables to this. Now we're going to hit apply, so we're going to keep this flag right here. But we need to create some scene variables, not object variables, because these are going to be accessible anywhere. So let's go into our top left, and let's go into our untitled scene and create some new variables. Now we're going to actually need 4 variables. We're going to need if the player has touched the flag. We're going to need flag X, flag Y, and flag Z. So let's start with the first variable, if the player has touched the flag. Now this is going to be a boolean. It's only going to be true or false whether or not the player has touched a flag. Now we're going to call this, let's see, P. Well, let's put player touched flag. This is going to be a kind of a long name, but as long as it makes sense, that's the most important part. So this is going to be player touch flag. By default, it's going to be false, and this is going to be checking whether or not we've touched a flag. Whenever we touch a flag, this will be set as equal to true. And we're going to add 3 more variables, and these are all going to be number variables since we're trying to store the position. This is going to be called flag X, and let me actually use camel case like a normal human being. We're going to have this as flag X, flag Y, And the last one, of course, you can already tell is going to be flag Z. And by default, all of these are going to be, of course, 0. So now that we have all of this, it's time to actually start making events that make this work. And of course, we do need to add our checkpoint onto the game. So I'm going to have our checkpoint right here. And let's change the Z position so it can be a little bit lower. Let's go into our 3D editors just so we can see things a little better. So we can change things more accurately. So I'm going to move around a 3D editor. And we're going to change things a little bit more accurately so we can really tell where our stuff is going. So just bear with me right now. We're going to set it up right here. And this is a pretty good spot right here. And we're going to set our size. The size doesn't matter too much because this is actually a pretty decent size. So you can really set this to whatever size you want. So this default size is pretty good. So I'm going to leave it here. So once you have the flag on the scene, it's actually time to start making your events for the checkpoint. Now, the first thing we want to do is have it so if we touch our flag, then we want to start saving flag X and changing flag X and flag Y and flag Z to be equal to the same position at the checkpoint so we can respawn the player there later. So let's go ahead and do it. So let's add a new event, and the condition is going to be if the player is in collision with flag. So we're going to check if the player is in collision. Once again, we're going to use the dotted ones since flag is not a 3D object, well, 3D physics object. If player is in collision with the checkpoint, then we want to do certain things. Now, the first thing we want to do is we want to set player has touched flag as being equal to true, because this will be useful for our death later. Because if player has touched flag is equal to true, we don't want to restart the scene. We just want to restart. We just want to spawn the player where the flag was. So let's add a new action. And let's change the variable player has touched flag. And we're going to change that as being to true. So once that's true, we want to also start storing the value of flag X, flag Y, and flag Z. So let's add a new action, and we're going to change another scene variable. We're going to change the variable flag X, and we want to set this as being equal to the checkpoint's X position of what you just touched. So I'm going to type in checkpoint.x. And you can already see where this is going. We can copy and paste this 2 more times and do something similar with flag Y and flag Z. So I'm going to copy this, paste it again, change flag X the second time to flag Y, and we're going to change checkpoint.x to checkpoint.y, change flag X again to flag Z, and you can't just simply put checkpoint.z because GDevelop doesn't support that exactly. Well, actually it just did. I swear they change things all the time, but I'm so used to the old GDevelop where you put flag.object3d.z, but you can do it like this too. I'm just so kind of old schoolish when it comes to GDevelop. Now, what we're doing right now is that, and this is actually when the player is at the beginning of the scene, but you want to make sure you drag this to if the player is in collision with checkpoint. Speaking of old timing, my memory kind of messing up a little bit when it comes to this. Now we have this, we have that simple error fixed. If player is in collision with checkpoint, then we want to have player touch flag is set to true. That's working. And then we're storing flag X. So flag X is now being changed to the checkpoint's X position. Basically, their positions are now being stored as the same value. Now, what does this have to actually do with us respawning? Now, what this has to do with us respawning is that now when P dead is true, we need to make another sub event. We need to make another sub event that is different whether or not player's touch flag is true or false. So I'm going to add a new sub event under this by clicking this event and then putting Shift D. And what we want to have as this sub condition is that if player has touch flag is true. So let's check this off. So we'll go to other conditions. Let's go into variables, variable value, and we want to check if player has touch flag is equal to true. We're going to check this first. And this is going to be a trigger once. And the other sub condition is we're going to be checking if player has touch flag is equal to false. So I'm going to copy this and paste it. And we're going to be checking here if player has touch flag is false. And the reason why we're doing this is that if the player hasn't touched the flag yet, we want to restart the scene. But if the player has touched a flag, that means we need to respawn the player wherever the checkpoint that he touched was. So, the first thing that we're going to do is that we're going to set player dead as equal to false. Because if we don't set player dead as equal to false, when the player respawns, it's just going to immediately die again. So let's copy it here since we already have that action. And we're going to set player dead equal to false. And now that we have this, now remember what's happening. Our player dies, and let's assume it's already touched the checkpoint. Our player dies here, and then we set p dead as equal to true. When p dead is true, it deletes the player first, then we wait 2 seconds. And since the player has touched a flag, this event is going to be run and not this. Now, we're going to have to create the player again because we just deleted the player. So now the player has to be created all over again. So, where do we want to create our player? Well, at flag X and flag Y of what we just stored. So we're going to click into our player, and we want to create the object. And remember, the X position is going to be flag X. So we're going to put flag X, and we're using the variable. We're not using the checkpoint, because if we just use the checkpoint, that'll only work for one checkpoint. This system works for an infinite amount of checkpoints. And for this one, we're going to put flag Y. We're going to put flag Y. Now that we have this, we're not done with this yet because it'll create the player at flag X and flag Y, but we still need to manually change the Z position of the player because GDevelop is currently limited, and when it comes to creating an object at a position, you have to set the Z right after. So let's add an action, and let's click into our player, and let's change the Z position of the player to be equal to flag Z. So let's go down until we find Z, and we're going to set this as flag Z. And now that we have this, remember, we deleted the player, and when you create an object, the object will respawn as default size. And what I mean by that, if I drag a player onto the scene, this is the size that I'll respawn at. And as you can see, this is slightly smaller than the player that we're currently playing. So whenever you respawn an object, you have to manually set the size all over again. So we can set the size right. Let's turn off keep ratio for a second, and let's round these to the nearest whole number. So I'm going to set this as 42, set this as 90, and we can keep that at 100. And we're going to keep the ratio. And you want to make sure you just have static values so things can be consistent. So go back into our events, and remember that our player size, we have 42, 90, and 100. So let's go ahead and set our player size as that. So let's change the size of our player, add an action here, click into player, and we're going to change the size. Remember right now the size action only supports width and height. We have to change the depth later. And if we remember correctly, the width was 42, the height was 90, and the depth was 100. So now we're going to create another action, and we're going to change the depth of the player to 100, which is, of course, the size on the z-axis. And we're going to set that as being equal to 100. So now these are all the events for checkpoint logic. And this will support an infinite amount of checkpoints. So if I die, I haven't touched a checkpoint yet. If I die by jumping into this kill box, I'll respawn where I was. But if I touch the checkpoint, then I die, you see that I respawn at the checkpoint. And this will happen every time I die. And just to show you that this works with several checkpoints, let's move this checkpoint farther back. And I don't want to go through the ground, but let's move this a little bit farther back. And let's also duplicate this. And we're going to duplicate this, and we have another checkpoint. Now, normally when you're making a game, of course, the checkpoints are going to get farther and farther in the levels. And there is something you want to keep in mind. Let's say I touch this checkpoint first, then I die. Of course, I'm going to spawn at that checkpoint. But if I touch this checkpoint now, I won't spawn at the other checkpoint. I'll spawn at the newest checkpoint that I just made. And this is good for when you're progressing in levels. You won't spawn at the last checkpoint you just had. Now, if you wanted to, this is just extra to make your game better. You could delete the checkpoint that you just touched. so that you can't ever touch it again, or you could deactivate it. But that's just extra stuff, because normally you can make your level where the player doesn't have to go all the way back, and normally the player wouldn't go back. But of course, if you want to just be extra professional, extra fancy, extra, just being all extra, you can do all that fancy stuff. It's really not that hard, but that's all the checkpoint logic. And the next thing we're going to be doing is adding an enemy that moves back and forth. Now it's time to get into making our very first enemy, and this enemy is going to be moving back and forth. Now, the important part about making this specific enemy is that we're going to be making an enemy with a cube as the hitbox and a model attached to it. And the reason why it's good to know how to do this when creating complete 3D games is that GDevelop, this model right here that we're using for the player, this works fine because the model matches this hitbox. Because when you're using collision events, it's going to be using this hitbox as its guide right here. This is what it's using. But when we're using our own cubes, we can have better hitbox control when we're using cubes, because right now GDevelop doesn't have very good hitbox features for 3D models at the time of me making this video. So using cubes to make more specific hitboxes helps you make more advanced games. So you need to know how to link a 3D object to a cube, a 3D model to a cube. So the first thing that we're going to do is create the cube, and that's what we're actually going to be moving using the events. So let's create a new model, not a new model, a new 3D box, because we're going to create the model after. So we're going to first create a 3D box, and since this enemy is going to move back and forth, we're going to call it EBF for short, which stands for enemy back and forth. And this doesn't have to react to lights. It actually should have no lighting effects at all, because this will be hidden anyway. So there's no need for it to cast shadows. Because just because you hide an object, if you don't set these off, it'll still cast and receive shadows. But of course, we do want to give it some faces so we can see it in the editor. We don't want to make it invisible or something like that. So we're going to actually create it with Piskel. All you have to do is just choose a color. If you don't have one already, just manage the palette and then use the bucket tool and paint it whatever color you want. So we're going to make this box purple. We're going to just make it a simple purple box. And I'm going to copy this text just like we did earlier in the tutorial. You can just copy it and you can paste it as all of the other faces with EBF. So we're going to be using this for our EBF. And now that we have this, one thing that we want to do for the EBF is that we want to make it a physics object, because remember, this right here is going to be doing all of the movement, and we're just going to be making a 3D model match its position. So we're going to set a behavior and we're going to add a new behavior. Now this behavior, once again, of course, you can already predict it. It's going to be physics 3D. So we're going to use the 3D physics engine, and we're going to make it kinematic, which means it can't move unless we use conditions and events and actions. So we're also going to set it as fixed rotation because there's no reason for us to want to rotate. So this is all that we need for EBF right here. So we're going to hit apply. And what you want to do is just drag it onto the scene so we can see it. We're going to drag it on here. And right now, this EBF, this is EBF. And I'm not sure exactly why it's giving us this instead of purple. It's just giving us like a GDevelop, that GDevelop 3D cube. Sometimes that may happen. Not sure why is happening here, but technically this is completely fine right now. So we're going to actually delete it because I think this is due to the 3D editor having that type of bug. Yeah, that's it. There's a 3D editor having a bug. Like I said, at the time of me making this video, GDevelop's 3D editor isn't 100% perfect. So when you're creating objects, I recommend you drag them onto the scene in the 2D view instead of 3D, because it can lead to bugs. So we're going to set the Z position. It doesn't really matter too much, but we'll just align it later when we get into the 3D editor, but this is fine. We're going to leave the height, width, and depth as 100, and this is all that we need right now for the actual enemy back and forth movement. So now we're going to have the model that we're going to be attaching to it. So we're going to add another object, and this is going to be the 3D model. And so we don't have a really long object name. We're going to call this EBF model, or you could call it EBFM, either way. And once again, we're going to import our file from our asset folder. And then once again, this can be any enemy you want. So this file that we're going to export here is going to be our orc. And it's this guy T-posing and doing a little silly T-pose, like We're not too worried about it right here. Just looks a little bit silly. And one thing that you do want to do is add an animation. Now it's going to have 2 animations, and we might as well just set them up right now. So by default, since we're importing this, if you're using the asset pack, by default it'll have animations. Once again, look up a Blender tutorial if you want to learn how to put animations in your GLB file. But we have 2 animations that we want for this. We're going to have a running animation, which is going to be as default, and we're also going to add a death animation. So make sure you have running and death. And it's better off to give these names instead of accessing them by number. It's easier in the event system to access them by name. So we're going to make sure we name them accordingly, and make sure you set run to loop. And this is not going to be too important right now. We're going to get to a little bit later, but we're also going to add the tween behavior to our orc, because if we don't add the tween behavior, when we move back and forth, it's going to do a little cheap little snap. But we want it to be a little bit more smooth since we're making a more complete platformer. So let's add a behavior, and we're going to tween. We're going to use tween. And now that we have the tween behavior, everything is all peaches and cream right now. Everything is good. So we're going to make sure we save our project. Now, when it comes to EBF, when it comes to the movement of it, before we start adding any events, we're going to add some object variables to our enemy that moves back and forth. So what you want to do is go to your EBF and add some variables. Now, we're going to add 3 variables. So the first one is going to be start X. And you can already remember from what we did with the moving platform. The moving platform and the enemy that move back and forth, their movement is basically exactly the same, because they both do the same thing. So we're going to use start X, just like we did with the moving platform. And also, we're going to add another number variable, and this is going to be called previous X. So for short, we're going to put prev X. And what this is going to do is, this is going to detect whether or not we're moving downwards or we're moving upwards. And the reason why I'm saying it downwards or upwards, because in our view, in the 3D view, even though we're changing the X position, it's going to look like it's moving up and down. So previous X is going to detect whether we're moving up and whether we're moving down, so we can change the rotation of the orc accordingly. And we're going to add one more variable, and this is going to be just like the player. And we're going to have a Boolean variable, and we're going to call this dead, because this once again will play certain actions when it detects whether our orc is dead. And by default, you want to set this to false, because we don't want the orc to start off dead. So now let's hit apply, and let's start adding some events. So let's get to the nitty gritty of this, and let's add some events. And this is going to be probably one of the most complicated parts of this tutorial, because we're going to be dealing with some object linking. But don't be worried about it. We're going to go through it step by step. So of course, just like we did with the other parts, we're going to add a new event, right click, and then add a new event group so we can keep everything organized. And this is going to be called EBF, which is, well, let's just call it enemy back and forth, because we want everything to be more clear when we're reading the events. You never want to come back and not understand what's going on. So we're going to call this enemy back and forth. Now, we first need to set up some things. Just like what we did with a moving platform, we're going to have a little bit of a setup of setting up start X. We're going to set up previous X, and we're even going to handle some object linking. So let's add a condition. And this is going to be at the beginning of the scene. So we're going to add that first. So we're going to go into other conditions, scene, and then check at the beginning of the scene. Now, one thing that we're going to do, this is going to be a little bit harder than making the moving platform. And this is because we have to keep everything flexible. We have to be able to create several of these EBFs and have them move accordingly. Like, they can't all be synchronized and moving exactly the same. And we're going to have to use repeat for each instance, which is something that I've covered in some of my earlier tutorials. Repeat for every instance. This is especially useful for enemies. So we're going to add a sub event first. Let's add a sub event below, and let's right click, and we're going to add another special type of event, and this is going to be repeat for each object. And this makes certain events specific to each instance. And what I mean by instance is that this right here is one instance, and if I duplicate EBF, this is another instance. And these two instances, you want them to be separate For example, just because this one dies, this EBF dies, just because this instance dies, I don't want this one to automatically disappear. So if we don't make distinctions like this, if one of them dies, all of them will die because the game thinks it's referring to all instances. So that's why we have to use repeat for each instance of EBF. So it can be very specific. So repeat for each instance of EBF. This is what we want to happen. Now, this is the main condition right here. At the beginning of the scene, it's going to repeat this for each instance at the beginning of the scene. Now, just like we did with the moving platform, we want to set up start X first. So let's add a condition because we want this to happen anyway. This is only going to happen once at the beginning of the scene, so you don't have to worry about it keep repeating. At the start, we want to set start X of EBF to be equal to the X position of EBF. So we're going to click into our EBF and we want to access our variables. So we're going to click into our object first, then type in variable so we can access the object variable. And we want to change start X to be equal to the X position of itself. So we're going to put ebf.x, ebf.x. And we're actually going to do the same thing for previous X, and it's also going to be set to ebf.x. So previous X, and like I said, we'll get into more previous X later. The logic, it seems kind of counterintuitive, like it wouldn't work, but it works great in my testing. So let's add another action, and we're going to set previous X as also being equal to enemy BNF or EBF. I just say the full thing sometimes. Enemy BNF. So we're going to change the object variable previous X, and we're going to set it to ebf.x as well. So it's going to be ebf.x. So now that we have these two set up at the very start of the scene, just like we did with our moving platform, we want to start getting into the object linking. And what I mean by object linking, let's drag in our EBF model so we can have things set up a little bit better. And I already have a preset size for our EBF model so it can match correctly with this. But remember, if you have your own model, you're going to have to do your own testing. I'm going to quickly set this width, and I recommend that you do it too. We're going to set the width to 68. We're going to set the height as 171. And we're going to set our depth as 117. And then you can put keep ratio again so that when you move it or change the size again, it can match. And this will match correctly with our hitbox right here. Now, that's not the point of what we're trying to do. I want you to understand object linking. This is going to have to be linked with this, because sometimes we're going to be calling certain actions, and if we don't specify that we're referring to this linked object, it will not change EBF model's properties accordingly if we're not referring to what is linked by. And this might not make a sense, especially if you've never did object linking before, but let's get into the conditions and events so we can understand it better. Now, when you're linking an object with another object, the first thing we want to do is automatically have a condition or an action that unlinks all objects from EBF, which is the parent. The parent object is this cube right here, and we're linking the model to the parent. But first you want to unlink all objects from EBF just to make sure that there's nothing that could be mistakenly linked to it. So let's add an action, and what we want to do is unlink all objects from EBF. So we're going to click into EBF, and then we're going to type in unlink, and we want to have unlink all objects from this object. So just in case there's somehow any objects linked to EBF, they will all be unlinked first. Then what we're going to do is pick the nearest object. So when we're creating our enemies in our game, if you're using the method that we're using in this video, which is a good method, whenever you create another orc, let's say you wanted 3 orcs, you'll have to duplicate this, you'll have to create an EBF, and then put an EBF model near it. Because what we're about to do is that for each of these instances, it's going to choose the closest model to the instance. So whenever you're creating a new one, you want to create an EBF model that goes along with it and drag it near the cube, because that's what it's going to be picking from. But we're going to delete this right now. So what we're going to do is pick the nearest model to our EBF. So we're going to add an action. We're going to click into EBF, and then we're going to put in nearest because we're trying to pick the nearest object. And we're going to make sure that we choose the nearest object to ebf.x for our x position and ebf.y. Now, GDevelop does have object picking for 3D, but for some reason it can support it when it comes to picking objects in its conditions, but it doesn't have 3D object picking for its actions. But for us, that's not going to matter here. Just place it close to it, and it'll work just fine because it's still choosing the nearest based off the X and Y. So that's not too much of a problem here because the Z just controls the height. But back on track, the nearest Y position we want to check is ebf.y. So now we're checking, well, we're picking the EBF. Actually, we're supposed to be picking the EBF model that's closest to this. So what we're doing right here is that we're first unlinking all objects from EBF to make sure there's no objects linked. And then we're picking the object, the nearest model to this position, which is EBF. Remember, it's repeating it for each instance. And now we want to actually link both of them. So we're going to add an action, click into EBF, we're going to type to link. We're going to link two objects together. And the second object that we want to link is, of course, the EBF model. So what we're doing, when you do object picking, the next condition after it will refer to the object you just picked. So it's going to pick the nearest one and then link it. So it's not going to link one randomly, because if you linked one randomly, it'll lead to all sorts of issues. So now this concludes the setup for enemy EBF. Now also what we're going to do is we're going to hide it. So I'm actually going to, we're going to do something similar. I'm going to put Shift A to create another event under. I'm going to copy at the beginning of the scene. And I'm going to once again, let's paste it here. Just paste it. We're going to create a sub event, right click, and add repeat for each object. And once again, you already know we're going to repeat for the EBF. And also what we want to do is at the beginning of the scene for each EBF, we're going to hide it. We're going to hide the EBF model. Well, not the model, the actual cube. So what we're going to do here is that we don't need a condition. We're just going to click into action, click into EBF, and we're going to hide it. And let's go click OK. If we preview, we're not going to see much because I don't know if our EBF is even in view. But whether it's in view or not, you won't be able to see your EBF because we don't want to see the purple cube. As you're going to see this little guy running around. But the model is gone. So everything is fine right now. You won't be able to see the actual box. So now that we have this, we want to actually handle it moving around. And like I said, the movement is going to be very, very similar, actually almost exactly the same as the moving platform. It's going to move back and forth very smoothly. So let's create a new event. And as you can already predict, we're going to use repeat for each instance. So let's right click, let's add, and we're going to add for each object. And we're going to click once again EBF, and we're going to repeat for each instance. Now, whenever we're moving around, remember, we created the variable dead earlier. We don't want the enemy moving around if it's dead, because that makes no logical sense. It has to be alive in order to move. So the only condition that we want here is to check whether or not the enemy is alive. So let's add a condition, and let's remember this is object variable, so we're going to have to click into EBF. We're going to type in variable and object variable value. We're checking if the variable dead is false. So now that we're checking if it's alive, now we want to get the movement together. And the movement will be nearly identical to this right here because they both work exactly the same. So we're just going to repeat what we did earlier. There's no need for explanation here. I already explained it earlier. So let's change the X position of our EBF. And once again, we're going to change the X position. So we're going to type in X position because that's what we're trying to change. And we're going to set this equal to EBF.variable. And this is actually an old school way of doing it. I just like doing it in this type of way for some reason. It makes it sometimes more clear to understand. And we're going to once again be using start X. Once again, if you want explanation, you can go back to when we made the moving platform. Plus 200. Once again, that's the distance. I'm still explaining it, but I just can't help myself. I gotta explain what I'm doing. So we have the sine wave, time from start. And once again, this is going to be an ever increasing value. That's what makes it move back and forth forever. And we're going to put multiply it by 1.5. Once again, I explained this earlier, but just as a little recap, this number right here controls the distance it moves, and this number right here controls the speed at which it moves. So those are the main things you want to edit when it comes to moving back and forth. So we're going to click OK. And now we're also going to want to change the position of our EBF model to always be at the center of EBF. And now when it comes, remember, these two objects are linked. So we have to tell our game that I'm trying to reference the model that's linked to our enemy right here. So you want to take into account all of the linked objects to that. So let's add an action. And we want to click into EBF. And we're going to type in link. And we want to take into account all of the linked objects that are linked to EBF. And we're going to click OK. And I did this a little bit reverse, actually. Let me do it not reversed. You want to click into the EBF model, take into account all linked objects to EBF. And I'm about to talk this out. So basically what we're saying here is take into account all of the EBF models that are linked to EBF. Remember, that's the parent. EBF is the parent. EBF model is the child. So we're taking into account all of the models that are linked to it, because technically it is possible to have several objects that are linked. And now we're going to change the position of that linked model. We're going to change that specific one's position to be at the center of our objects right here. So let's add an action. And let's click into our EBF model, and we want to set a center position. We want to set a center position, and for our X position, we want to set this to EBF.center X. And we're going to do a similar thing for the Y position. We're going to put EBF.center Y. And basically what we're saying is that we're setting the center of the model to be equal to the center of the box. And let's go back into our scene and just see some things. Let's click into this. I'm going to drag this down. Just drag this down to the scene. I'm going to temporarily move this out of the way so we don't have to worry about it. And it's already the nearest one, but you can make sure you put your EBF model close to it, because it's going to automatically snap it on there anyway. So it really doesn't matter. It just needs to be close enough to it. And once again, it is important that you try to snap your cube to the ground. Sometimes it can be kind of hard to move everything, but you want to look around, rotate your camera, and make sure that the gap between the ground and your cube is not that big. Because remember, this thing doesn't move to the ground automatically because it's not dynamic. So let's go preview and see what happens right now. If we preview, we're going to have some issues. You see it moving back and forth, but there's no enemies. And also, it's not matching the Z position or the height. So this guy's just moving around like an absolute goober. He's just doing whatever he wants. So we're going to have to control him using some events. So now we want to change the Z position, the center Z position, to also be equal to the center Z position of EBF. So let's go ahead and add another action. Let's click into our EBF model, the center. I'm going to type in center, and you'll see that we have an action for center Z position. And as you can already tell, we're going to set this to EBF.Z, well, .center Z. Now, it's not as simple as using center Z, because you see that we don't have center Z, but we do have object 3D center Z, which is, it does the exact same thing. I don't know why they haven't added it so you can do center Z yet, but hopefully it's something they add in the future. But you will have to add EBF.object3D and then center Z in order to make this work. So now when we preview, it should actually be on the ground and he can stop trying to do his own thing. Now it is a little bit high. You don't see much of a difference. And when this happens, it just simply means you're going to have to move the cube down some more. I'm going to try to move it down some more. And let's see what happens here. See, that's a little bit closer to the ground. He's still kind of doing his own thing, but like I said, you kind of just got to tweak the value so it can just be better. I'm just going to move it down a little bit more. Now you see it's kind of walking on the ground. So this is much better. Just make sure you tweak your value of your cube. It might just be looking like it's on the ground like this. And now that we have this, we're going to be handling some of the animations. Now, by default, we're going to set it equal to run. So if it's alive, we're going to change this animation to run. We already have that as the default. But if you don't have it as a default, you would definitely have to do this, because you might want to have another default. You might have an idle animation as your default. So when it's alive, we want to set the animation of EBF model. We're going to set the animation. Then type in animation, change it by name, and we're going to set this as equal to run by default. I'm not going to preview again because nothing is going to have changed. And now that we have this, it's time to actually set up our enemy like turning around when it moves backwards. So for this, we're going to be using previous X. And this is going to be some very simple calculations. Like I said, it seems like it's something that wouldn't work, but it does work. So let's add two sub events. And basically what we're going to have is if previous X is less than, well, if the X position of EBF is less than previous X, then we're going to make it move like backwards. It's going to be rotate backwards. But if it's not, and actually by default, let's see, by default it's kind of rotating forward. So that means it's going to be backwards. Yep, by default. So basically if EBF.x is less than previous X, then it's going to be rotated backwards. And if EBF.x is greater than previous X, it's going to be back rotated in its normal position. So the first thing we're going to be doing is removing a tween. And I know you're like, we haven't even added a tween yet, but we're going to be swapping between two tweens. So every time we activate these actions, it has to remove the previous one first and then activate a new tween. But before we do that, we need the condition. And our first condition is for if it's moving backwards. So let's add a condition, and we're going to be comparing two strings. So I'm going to type in compare two strings, or two numbers, not strings. The strings is text. And the first expression that we're going to have here, well, we're checking if it's less than. Remember, we're checking if EBF.x. My brain's all over the place. If we have EBF.x, we're checking if it's less than EBF.previous x. The previous x is just tracking how far away we are from our original. So previous x. And I keep trying to put parentheses. We don't have to do that anymore. That's that old school GDevelop. And you have EBF.x. We're checking if it's less than EBF.previous x. And we might as well go at this for the sub event under. So we're going to be checking. Let's go ahead and copy because it's similar. Copy. And then we're going to paste it. We're checking if EBF.x is greater than EBF.previous x. And now that we have this, remember, we're going to remove a tween. Now, I know we haven't started the tween yet, but we're going to remove a tween from it. So let's click into our EBF model, because that's the one that actually has the tween. And we're going to type in remove a tween. Now, it's going to be giving you an error like it doesn't know what you're talking about first. But we're going to call this tween EBF rotate. I'm going to put underscore so it can be like a little bit more clear. EBF rotate. And it's not really screaming at us, so that's fine. But if you try to run it, you might get an error. And now it's time to do the actual tweening. Remember, this is for if it's moving backwards. So we're going to be tweening the angle of our model. So we're going to click into EBF model. We're going to type in tween. And we're going to be doing a tween of its rotation. So what you want it to do is tween an object value. Well, not the object value. Let's do the rotation right here. And let's see if I can just type in tween rotate. Tween a rotation. So this would work right here because we're tweening a rotation on the x-axis right here. So this is all good right here. So, well, actually, let's tween the angle. Let's tween the angle. Tween object angle, because that will access it in the right manner. So the tween identifier, that's just the name of the tween. Remember, we already made one, EBF rotate. And what is the angle that we want to change it to? We're going to put 180, so that means it'll be moving backwards. Do not destroy the object once the tween finishes. You will kill him. Do not do that. You will absolutely kill this guy. So the duration in seconds, this can be whatever you want. If you set it as something larger, it will be a slower movement. So you want to normally set it as something small. I have a set value, 0.12. This is pretty good. If you want to make it faster, set this as something even lower. Once again, if you want to make it slower, you can set it higher. There's also a bunch of different types of tweens. Of course, I don't have every one of them memorized. I'm not about to explain all of them here. But these are different tween effects if you want them to look a little bit different. but linear is fine for what we're doing here. So we're going to keep this. And also, we're going to be doing the exact same thing, but except for this one, this will check if we're going forward. So we're going to right click, copy, and paste it. And we're going to right click, copy, and paste this. But instead of tweening the angle to 180 degrees for this one, we're going to tween it back to 0. And we're going to add one more sub event. I'm going to put Control A under this one. Make sure that when you're dealing with these sub events that these are together, and you'll know that they're together because of the drop down menu. And we're going to set no condition. We're going to set previous X to always be equal to the X position of EBF. So we're going to go into our other actions. Well, not other actions. EBF variable. We're trying to access previous X. And we're going to change previous X to always be equal to the current X value that we have. So EBF dot X. It's really hard for me to give an explanation because making these, it works for some reason, but it's hard for me to explain why it works in a sense. But if anyone has a better explanation than this, I did say that these check which direction you're moving in, but I'd love to hear it in the comments. But that's the best explanation I can give for this right now without like talking all day long. But these are just detecting which direction it's moving in. If it's less, it moves backwards. If it's greater, it moves forward. So let's do our preview to see if everything works right now. And it's working very well. And this enemy is actually quite big. This guy's like very, very big. But whatever, it's all cool. It's all cool. But right now, you see that we have a few things that are going on. We don't die when we touch him. And right now, when we jump on his head, we can just stand on him, I think. If I can actually aim it right. Like, he really don't want me to stand on his head for some reason. But we have a few issues right now. We have to make it so this guy can actually die. He's not an enemy if he can't die. So, now that we have this, we're going to get into creating the death of our enemy. Now it's time to finish the events and actually allow the player to bounce off of the enemy's head and allow the enemy to die. But before we do that, we do have an issue that was in the last thing that we made. And that is that we don't want this clipping through the ground because we're about to be doing some detections for the bouncing of the player. And this means that this is going to have to be upright on the ground. Now, I did a miscalculation here. In order to stop the clipping of your object, this depends on the type of cube that you have. But for this cube set specifically, instead of changing the center Z position, we're going to change the Z position in general of the Z position. So we're going to change Z position, not tweening it, but we want to change the Z. So we have Z elevation right here, and we're setting it equal to, we can keep this EBF.object3D center Z, but we're going to do -50. And once again, you want to have your enemy upright, but you want the model to also be upright and on the ground. And this depends, these values will all depend on how your models look. It's more or less not about the cube, but it's about how your object itself looks. So you'll have to do your own testing if you're not doing these right here. Just know this will be the main value that has to be tweaked if you have your own custom models. So we're going to preview this, and things should look better if we're not clipped into the ground. As you can see, things do look much better now that our object is barely clipped. As you see, we have a little bit of space right here, so we're going to remove that space. Then we're going to preview it. And now our our enemy's feet are really locked onto the ground and is accurate to the position of our cube. So this is working fine now. So now that we have this, it's time to set up the logic for the enemy dying. It's time to set that up. So what will the enemy dying be based off? What will the condition be based off? Well, of course, the player has to be colliding with the enemy, but that's not enough. Because if we just check that, how will we know if the player's over it? We have to have a bounce effect. So in order to check if the player's over it, we have to check if the center Z of the player, if it's greater than the center Z plus a certain value. This depends on your model. But we have to check if the center Z of the player is greater than the center Z of the cube or the EBF. So we're going to do that right now. So once again, we're going to click this, put Shift A to add a new condition or a new event under it. And once we have this, once again, like we always do, we're going to put repeat for each instance of EBF. So we're going to right click, add, and we're going to put for each object. And now once we have that, what we want to do, of course, click EBF. So we're repeating for each instance of EBF. Now, when we're doing this right here, of course, we want to check if the enemy is not dead. Because if the enemy is dead, we don't want to be able to keep bouncing on him, because you normally can't do that in games. So first, we're going to check if the enemy is actually still alive. So we can just copy this right here, copy, and then paste. And now we know that we're checking if the EBF is still alive. So we're checking if dead is false. Now we also want to check if the player is colliding with EBF. But of course, we're going to have another condition, which we're about to get into right now. So we're going to add another condition. And remember, like I was saying earlier, these two objects, player and EBF, these are both physics objects. So when we click into player and type in collision, is already at the top right here, the collision will have this icon next to it. It looks kind of like an atom, something in the middle, and you have all these lines. And now we can use this since these are two physics objects. And we want to check if it's in collision with EBF. Now that's not enough, of course. Now we also want to check if the Z position the Z center position of the player is greater than the center position of EBF. So we're going to add a condition. We're going to be comparing, well, not comparing two numbers, because we can just access the center Z of the player. So let's type in center Z. And now what we want to do is check if it's greater than. So we're checking if it's over the object. So now we're going to check if it's greater than EBF dot center Z. And we already have center object 3D Z. And we're going to put plus 20. This is from my own testing. Depending on your player model, this will be different. This value may have to be a little bit higher or a little bit lower. But just make sure that when you're over the player, not over the player, over the enemy actually dies and not you dying. Now, when all of this is true, now we want to actually kill the enemy. So when we kill the enemy, the first thing we want to do is set dead equal to true, because now dead is equal to true. The enemy is going to die. So we're going to click into our EBF. We're going to access the variable, and we're going to change the object variable value of dead equal to true. And once we have that, we also want to do a few other things. Remember, we want to start bouncing off of the enemy. And when we're bouncing off the enemy, it's not very complicated to do. All you have to do is allow the player to jump again. And then we're going to simulate a jump key being pressed. So we're going to add an action. And when this happens, we're going to click into our player. We're going to put allow jumping again. And basically what we're doing is we're giving the player an extra jump for a split second. Then it immediately simulates that jump. And this will perfectly simulate a bounce. Now, normally you don't want the bounce to be as high as your jump. So what we're going to do is quickly change the jump speed and then simulate the jump. When actually, I believe our jump speed is actually the same as that right now. So let's double click into our player. It doesn't matter too much, but let's check our jump speed anyway. Let's scroll down to behaviors. And you'll see our jump speed is, jump height is 200. So the bounce, I believe, is going to be pretty high then. Yeah, the bounce is going to be quite high. Because right now our jump speed is, or jump height is 200. So it's pretty much fine. This is all fine. Advanced properties. Yep, we have everything all good. So the bounce actually might be pretty high, but let's go do it anyway. Let's add an action. Let's click into our player. We're going to go into jump speed. And jump speed, we're going to set this as 600. Once again, if you want to make the bounce lower, you can set this as a lower value. And now we're going to simulate a jump for the player. So we're going to type in simulate. And you see right here we have simulate jump key press. And now once we simulate that, so we choose the right enemy to set his animation to death, we want to make sure that we take into account all of the linked objects that we have to EBF. So we're going to add an action right here. We're going to click into EBF, and then we're going to, EBF model is what we click into. We're going to take into account all of the linked objects, and then, of course, what we're taking into account is the linked objects from EBF. And now, since we're taking this into account, it will choose the correct enemy, and then it will set its animation to death. So we're going to set the animation of that enemy that just chose to death. So we're going to click into EBF model. we're going to type in animation. We're going to change the animation by name, and we're going to set it equal to death. And now when we do that, we have a few more things we want to do. After that is done, we want to wait a few seconds, and then we just want to kill the enemy. And what I mean by killing it is we want to delete the model, and we want to delete the enemy itself, which is EBF. So I'm going to create two sub events. We're going to create this sub event, and then we're going to create a sub event of that sub event. Now, an easy way to wait after this, because you don't want to just wait 2 seconds here. That can lead to some problems if you only wait 2 seconds here and then try to delete it. For my testing, sometimes that leads to bugs if you don't use sub events. It's better to use a sub event for that wait, and it also makes it a little bit more clear, so you don't have to stack a bunch of actions in one little space right here. But you could do either one. I kind of like doing it this way. So we're going to do wait 2 seconds. We're going to go into other actions, timers and time, and we're going to wait 2 seconds. And once we wait 2 seconds, after that, this sub event will play. And what we want to do is delete the model, and we're going to delete the enemy itself. So we're going to click into EBF model and delete that object. We're going to create another action, click into EBF, and we're going to delete that. And let's see if this all actually works. Let's preview this. So you see it walking around, this guy being a goober. We're going to jump on his head, and you see that it dies. But we have an issue. We were just standing on absolute air because his hitbox is still active. And what I mean by the hitbox is that EBF model's hitbox is still active. Just because it stops moving doesn't mean that it's not active. It's not going to magically become inactive until it's deleted. So in order to do this, we need to make it so if an EBF is dead, we disable the hitbox. So let's go ahead and do this. Now we're going to add a new condition or a new event. I keep saying condition, but we're going to also repeat this for each instance of our EBF. You can already predict that we're doing that by now. And we want to check if the enemy is dead. So we're going to actually copy this right here if the enemy is alive. And now we're checking if the enemy is actually dead. So we're checking if dead is true. And if dead is true, all we want to do is disable the mask. And what I mean by mask is that this object's hitbox is only active because it has a mask on it. And what I mean by mask, if I double click into EBF and I scroll down into on this behaviors, you'll see that we have masks. And masks are only available through 5. If you try to access anything less than 5, it's not going to work. But if I disable 5 for this EBS mask, you won't even be able to collide with it. This is what decides the collision. So you can disable certain masks. And you can get more advanced with this, but that's just a simple overview of masks. But all we're going to do is just disable the mask when it's dead. So if EBF dead is true, we're going to add an action. We're going to click into EBF. Let's type in mask. It's going to ask you to enable it. But we're disabling it. So all you have to do is keep no right here. It's going to ask you mask 1 through 8. For my own testing, 1 through 8 don't even work. You have to be at least 5. And there's a deeper reason behind that. But like I said, we're not going to get into all of that right now. That's for a different tutorial. So now let's go ahead and jump on the enemy's head. And you see that we can no longer collide with it. We can actually walk through it. So everything is working fine right now. Now the only thing that we need to do here is now make it so the player can also die if it's not above it. So let's create a new event. And actually we already had one under it. So I'm going to just go ahead and delete that. And once again, you already know the drill. We're going to put repeat, not event group. We're going to put repeat for each instance. I'm going to a little bit all over the place. Got a lot that's going on right here in this project. But we have repeat for each instance of EBF. We're repeating for each instance. And now, once again, we want to check, of course, the enemy has to be alive. We don't want to be able to get killed by the enemy if it's already dead. So we're checking if it's alive. So I don't have to redo that. We can just copy and paste it. We're also checking if player is colliding with EBF. We don't have to redo that. We can also copy and paste that. And now we're going to be checking the opposite right here. So instead of checking if the Z position center of the player is greater than EBF center plus 30, now we're going to check if it's less than or equal than. So we're going to copy this, and all we have to do is change the operator in between. So we're going to paste it right here, and we're going to change the operator in between. So we're going to check if it's less than or equal to, and we're going to put trigger once. And trigger once is important because if you don't put trigger once, there's a possible chance that it thinks your player died 2 times, and then when you respawn, you'll have a whole twin with you. And I'm not even joking, you will have a twin player with you if the game detects that you died 2 times. Because it will respawn you back 2 times because it thinks you died 2 times. So it's important to put trigger once when you're dealing with the death. So let's add a condition, and we're going to go into other conditions, and then we're going to put trigger once. Nothing else to configure here. And when that is set, remember we already set up events earlier to handle our death. So all we have to do is set player dead to true, and our previous events will handle the rest. And that's the advantages of making proper events. All you have to do is set a variable to true, and it will handle everything for you, depending on how you create it. So we're going to click into player, type in variable to access our death, and we're going to change the object variable, not the modify the number one, but let's go click into, I forgot it's a scene variable, my bad. I'm so used to dealing with object variables right here. Just bear with me right here. We're going to change player dead as a scene variable set to true. And once we have this, everything should be fine. We're going to wait for it to load a little bit. It's just testing our patience. Don't ever crash out on GDevelop because it's trying to load. Don't do that. Now that we have that, if we just run into it without jumping over it, we will die. But we'll respawn back. Like I said, run into it again, we will die. But if we jump on it, we won't die. And that's exactly what we want to happen. Once again, as a recap for this part, I want you guys to definitely, if you do not understand this part, definitely rewatch it. Because this is the most complicated part of the project when you're dealing with this object linking. Because you definitely want to link properly. Because if you don't handle the linking right, you won't be able to have several enemies. And also, you want to make sure that these positions are set up. If you have a custom model, you're going to have to change these. You won't be able to get away with these exact values that I have here because I've already tested these to make sure that they work properly. And another thing is that, remember what I was talking about earlier with adding several enemies? What do I mean by that really? Now, adding several enemies, whenever you want to add a new enemy when you're linking, you want to create the EBF first and then put the model as close to it as possible so it would choose it. And then if I want to create another EBF, let's go ahead and duplicate this. We duplicate the model. And now let's duplicate the EBF itself. And we duplicate that. And you want to put them close to each other so that they're being chosen properly. So I'm going to put these guys side by side. It's going to choose the closest one to it. Make sure you're always setting the models as close to each other so they don't pick the wrong one. And let me just rotate a little bit. And now if I preview, we'll have 2 separate enemies that die on their own. They do everything on their own. So if I jump into this one, it dies, and the other one's still alive. If we don't do proper linking, they both would die at the same time. Jump into this one, it dies, and we're all good. Everything is completely good. So everything is fine right now. One thing is that also the jump gets a little bit lower, and that's because we have to reset our jump speed. So our original jump speed, we go into our player, we double click into our player, we go into the events. You see that our jump height is like 200. And jump speed, the thing about jump speed is actually kind of weird because you don't even see it in here. That's kind of the weird part about it. But let's go ahead and change our jump speed anyway when we touch the ground. So let's put this in. I guess we'll put it up here. This is just some basic stuff. So let's type in, we'll click in player if it's on the floor. If it is on floor, we're going to click that. We're going to change the jump speed. So we're going to click into our player. I'm going to scroll down to its properties. And they don't have jump height up here. but we want to change the jump speed. And we might as well use jump speed instead. I think there's an error on their part that they have jump height and jump speed separated, but we're going to set it at the beginning of the scene to also be 800 as well, so it can be higher than usual. So we're going to put other conditions, scene at the beginning of the scene, and we're going to also set it to 800 because you don't want to have your player suddenly jumping lower after it hits an enemy. So right now, yeah, that was pretty accurate to what it used to be. We jump that high, and when we get back on the ground, we still jump that same height, but our bounce is also low. So that's how you pull that off without having a buggy and glitchy game. And the next part, we're going to be making a boss, which will also serve as us learning follow AI at the same time. All right, we're almost to the end of this tutorial, but not quite yet. We have one more mildly difficult thing to do, and that is going to be making a boss. And this boss will simply follow the player, and you have to hit it 3 times in order for it to die. And like I said, this will serve as a boss and follow AI, because follow AI is very, very common when it comes to 3D games. So, before we even start making the boss, let's actually clear some space. We're going to delete both of these enemies. We're going to delete the ugly ogre guys, not even ogres, orcs. And we're going to like expand our land a little bit. So we're going to just scale it out. And we're going to scale it sideways just to get a little bit more space. Scale it a little bit backwards as well. Give it a little bit more space. Even move this up a little bit. Just making sure that we have enough space to do what we want to do. So as I quickly do this, I'm going to just move this up. It doesn't really matter. I'm just very precise about where I want things, so just bear with me for a second. And you can do this as well to get some more space before you get ready to make your boss. Okay, now I like this format that we have right here. So let's go ahead and start making our boss. Now remember, the first thing we're going to need to do when making our boss is, of course, create the boss object. And we're going to have a boss and we're going to have a boss model, but we're not going to be doing all the object linking again because normally you have one boss. But just know that if you do want to be able to create several bosses at the same time, I don't know exactly why, maybe you want several bosses, you will have to do object linking, and you can just refer back to enemy back and forth if you want to do object linking with your boss as well. But this is going to just be singular objects where you don't have to do all that linking. So we're going to create a boss, and once again we're going to have the box separate from the model. So we're going to create a 3D box, and this is going to be called boss, of course. And we don't want to shadow cast or shadow receive, and we're going to have no lighting effects at all. We're going to do a very similar setup to what we did with EBF. I'm going to use gray as our color here so that everything looks different in the editor. And like we did last time, we're simply going to copy and paste all of the text into the faces so we don't have to keep going through GDevelop's UI, which is slower than this. So now we have all the faces filled up. We're going to add a behavior. Now, just as something a little bit different, you don't have to make your enemies be kinematic. You know, that is most of the time the better way to do it. You can also make them dynamic. So we're going to type in physics 3D, and this one is going to be a dynamic physics object. So we can keep the type at dynamic, which means it'll actually fall down. If this boss can fall off and fall down, and it'll actually use these properties, because when you're using kinematic, it doesn't use these properties because it only moves by events. But when we're using dynamic, you can control things like friction, restitution, angular damping, and the linear damping, as well as everything else when you're using dynamic. We're going to keep this at fixed rotation though. It doesn't really matter too much because you can't even see it, but we're going to hit apply. Now, there's almost no reason for us hitting apply right here except for us dragging onto the scene. And remember, I recommend that if you don't want to have any chance of bugs, definitely want to drag it onto the scene when you're in the 2D view. GDevelop's 3D view is very new at the time of me making this, so you'll be better off just dragging it in using the 2D view. Now, it doesn't really matter where you have it in terms of height because it's going to fall on the ground anyway. But let's double click back into our boss. Now, what makes the boss different from enemies is that they have health. And we're also going to have speed that we can control as a variable to make things a little bit more flexible. Because you could control speed using the events, but I'd rather use a variable for this. So let's add these variables. So we're going to, both these are going to be numbers, of course. The first one is going to be called health. And I can't spell apparently, but we have health right here. And this is going to be set to 3. It's going to be kind of like a Mario boss. You hit it 3 times, it dies. And we're also going to have a variable that's called speed. And speed are, of course, I've tested this using my own testing, so I know exactly what to set it to. You can set this to whatever you want, but I'm going to set the boss to a speed of 5. But this way we can easily edit the speed without having to continuously go into events. We can go here or use events. It doesn't matter, either one. But we're also going to create one more variable, and this is just like the boss and the player, well, just like the enemy and the player, and this is going to be called dead. We want to check whether or not the boss is dead, and by default it's going to be a boolean, and it's going to be set equal to false, because we're going to be using this a lot. There's going to be a lot of similarities between making this boss and making an enemy. Now also, before we get into the events, we also want to create a boss model, which we also have. So I'm going to go into our scene objects, create another object, and this is going to be a 3D model. Once again, we're going to call this boss model. So let's go ahead and add the boss model. So we're going to go into files from our device, and we're going to double click into our alien that we have here. And once we have the alien in the game, everything should be fine. It's going to cast shadows, but we are going to have 3 different animations. We're going to have this walking animation, we're going to have an animation for when it receives and hit, and we're going to have a death animation. So we're going to add 3 of these. Add one, we're going to add another one, and add a third one. Now, of course, the first one is going to be walk. Remember to name these accordingly so they're easier to access. Walking is going to loop. Then we're going to have hit receive, and hit receive is not going to loop. So hit receive, we're not going to loop it, and also death, we're not going to loop it. So we have all of these that we have right here, and that's basically all we need to do in terms of our boss model. It's not going to have any tweening or anything like that like we did with the enemy. So this is fine right here. Just make sure you have the loop set properly on the walk. So now that we have this, we're going to drag the boss model onto the scene, and it's doing that thing again. So let's go ahead and click it and delete it so we don't have to deal with that. And we're going to go back into 2D, and we're going to click into our boss model and drag it onto the scene. And we're going to set the size. Once again, I have preset sizes that match with our box. You're going to have to do your own testing if you have your own custom assets for your game. So we have 58, 116, and 98 for our boss model, and this aligns properly with what we have. The position doesn't matter because we're going to line it up using events later anyway. So now is actually time to make the events for our boss. There's going to be a lot, but it's not going to be as complicated as the enemy was back and forth, because we're not going to have to keep using repeat for each instance because we only have one boss, and we're not going to have to handle any linking. So the first thing that we want to do is that at the beginning of the scene, this is technically not necessary, but I like doing it anyway just in case sometimes you may not want to have walk as your default. But at the beginning of the scene, we're going to set walk as the default animation for our boss model. But before we do this, let's keep the organization together, add a new event group, and we're going to call this boss. Drag the event under, and at the beginning of the scene, we're going to set our boss model animation to walk. Let's go into other conditions, scene at the beginning, and then we're going to set the animation of boss model to be equal to walk. So we're going to click into boss model, type in animation, and then we're going to change animation by name, and you already know we're going to set it to walk. Now, the next thing that we're going to do is immediately get into the movement of our boss, and we're going to be using a complicated formula that looks like Einstein made it, but I'm going to explain it to the best of my ability. And also the most important part is telling you how to edit the values so you can actually make things customizable. You're not stuck with a formula that you don't know how to use. Now, the only condition that we need for whether or not it can move is that we want to make sure that the boss is alive. So we want to check if it's not dead. So let's add a condition, click into our boss, remember, not the boss model, and we want to access the dead variable and check to see if that's false. So we're checking if dead is false. And if it is false, then we'll be able to actually move. So when it comes to movement, the reason why I also made boss a dynamic object is because you want to know how to make AI with dynamic objects. And when you're using dynamic objects, it's not as simple as just changing X positions and things like that. Especially since we're trying to make a follow AI, we're going to have to use some forces. So we're going to be adding a force to the boss. So let's go click into our boss and we're going to apply a force. So I'm going to type in apply a force at the center. We're going to be applying a force at the center of our boss. Now, we're not going to be using the X, well, the Z position or the Z component. We're going to be having this as 0 because remember, it's only moving on these axes. It's not moving up. So you don't have to have a Z component in terms of the force that you're adding to it. And now it's time to get to the Einstein formula, what I call the Einstein formula. It's really not that complicated, but when you see the cosine and the arctangents and things like that, you're going to think it's just crazy, but I'll tell you how to edit it. So I'm going to start by typing it silently like a psycho. And maybe not silently, that's maybe too psychotic, but we're going to type it. So we're going to put boss.variable. You don't actually have to do this. I'm just old school. We're going to put speed. So we're accessing speed. You could actually use boss.speed, but I'm just an unk. So I'm going to put boss.variable speed. So we're accessing the speed and we're multiplying it by cosine. And here's where the Einstein stuff comes in. We're going to put cosine. And then we're going to put, after the cosine, we're going to put arctangent. So that's going to be a tangent. And this is going to be a tangent too, because we're trying to get two things. We're going to put player dot y, and then we're going to put minus boss dot y. Like I said, this is going to look absolutely crazy when you first see it. And then we're going to put a comma after this, after the boss dot y, and we're going to put player dot x minus boss dot x. And now we have the first part of the Einstein formula. I'm going to explain this after, but we're going to get the second part of the Einstein formula. And this is going to be more with the y component, which will move it around up and down. And the other one is going to be, of course, left and right. So we're going to have boss.variable. Once again, the unc method, I just like using variable. You don't have to do that. Once again, you can do just boss.speed. Boss.variable speed. And I'm going to put multiplied by part of the Einstein formula. Sine. And we're going to put arctangent. And then there's going to be arctangent 2 since we're trying to access two things. And then I'm going to put player.y. And I'm going to also put minus boss.y. And then also, comma, I'm going to put player.x minus boss.x. You can already see the pattern right now. So now we have the Einstein slash unc formula because it includes boss.variable speed. We don't have to do that, but that's what makes it the unc part. Now, this is the X component. And when I explain this, let's click OK first and get out of here. When we're moving our boss, remember, look at the X. If I move this upwards, you see that it goes up. So in our case, X is actually making it move up and down. And this is just in our perspective right here. And Y, if we change the Y, that'll be making it move left and right. In our perspective, of course. So this right here, when we get into speed, if you want to make the boss faster, all you have to do is change the speed variable. You can change that either using an event at the beginning of the scene or just editing it through the object editor. And that's how you change the speed. But then we're multiplying it by this. Now you have this Einstein part. The cosine, you see the only difference between these two formulas is cosine and sine. It's just cosine and sine. Because basically you also have inside of here player.y minus boss.y. This is the way that the game and that the enemy is tracking, well, the boss is tracking the player's position. That's why we have this. we're tracking the player's position, and we're also with the arc tangent. This is telling the enemy which way it needs to be facing. So that's the importance of the arc tangent right here. And that is the importance of this inside of here. These are exactly the same inside, but the only difference is sine and cosine. If you want to move up and down, you would use cosine. And if you want to move left and right, you would use sine. So that's how you actually edit this formula. Once again, we don't need this for z. If you want to make it fall on z, you could just set the position as equal to the z position of the player if you want to make it follow exactly. But that's how you use this Einstein formula. It's really not that complicated. Remember what's inside. This is how the enemy or the boss tracks the player. Arctangent controls how it faces the player. Cosine, up and down. Sine, left and right. And you can rewind that if you want to, but that is the Einstein formula and how to edit it. Now that we're done with the Einstein formula, we have the boss can actually move. And let's preview the scene and see how it moves. So if I preview this, see that it starts moving towards us and it's kind of scary. It's very big, it's bigger than us. So we have the boss moving around. But right now it can't kill us, so it kind of just stands on our face and we can push it around and stuff. We can bully it. But we want the boss to bully us, not us bullying the boss. We can even ride on it. It's pretty cool. And it just rides you into his death. Now, we have the movement done. Now it's time to make the bounce just like we did last time. Now the bounce is going to be pretty easy, but we also want to change the animation of the boss to hit receive during this point. And we also want to subtract health from the boss. And we're going to make the boss faster. So we're going to do a similar thing of what we did last time with the hit detection for our boss and making the player bounce off of it. So I'm going to put Control A, add a new event. And the first thing, of course, we want to check is that whether or not the boss is alive. We want to make sure the boss is alive. So we're going to click to boss, go into variable, and we're checking if the variable dead is false, because that means that the boss is actually alive. We also want to check if the player is colliding with the boss. So we're going to click into our player, and once again, these are both 3D physics objects, so we use this one. And we're doing if it collides with boss. So we're checking if the player collides with boss, and we're going to do a similar thing. We want to check if the center Z of the player is higher than the center Z of the boss to make sure that we're over it so that we bounce on it instead of dying. So we're going to add a condition, going to click into player, type in center Z. This is just like what we did earlier with the enemy. We're going to put boss dot object center Z, and it'll already know that, well, dot center Z. You can easily auto complete it instead of typing object 3D center Z. And once you have this right here, this is from my own testing. Remember, this is based off the size of your boss. But in order for this to work with our player model that we have here, I add plus 20. Once again, you have your own models in your game. You're going to need to edit these values accordingly. And now that we have this, we have the plus 20 here. What are the actual actions that we want to happen? It's going to be the same as last time. We want to allow the player to jump again, set our jump speed, and then simulate the jump key. So we're going to do exactly that. Player, allow it to jump again. I'm going to get through this quickly because we already did this earlier with the enemy. We're going to set the jump speed once again. Jump speed. We're going to set that equal to 600. And then we're going to simulate the jump key press so it actually bounces. Click into player, type in simulate the jump key press, and here we have it. So we got through that very fast because we already know how to do this. We're coming closer and closer to masters at this. Now we're going to have a sub event, and that's going to be a trigger once, because the next things that we want to happen, we want to make sure that they only trigger once. So we're going to click this event and put Shift D to add a sub event, and we're going to put trigger once here. And now that we have trigger once while true, we're going to click this, trigger once while true. And the first thing that we want to do is change the animation of the boss model to hit receive. That's what we're going to do first. So you'll see it, and you'll think it's borderline useless because it moves so fast, the animation for this boss, that you can barely even see it, but we're going to do it anyway. We want to click into our boss model, and we're going to type in animation, and we're going to change the animation to hit receive. hit receive. And after this, remember, when the boss gets hit, we also want to subtract health from the boss. We want to subtract health from the freaking boss. And I said freaking, we're getting a little passionate about this. So we're going to click into our boss. And once we do this, once we click into the boss, we're going to set our health. So I'm going to type in variable. We want to access an object variable. And we're going to put health. And we're going to put subtract 1. And for the speed, we want it to get faster. So we're going to add 2 to the speed every time it gets hit. So I'm going to copy and paste this so we don't have to go through those menus again. Double click. We're going to change the variable speed and we're going to add 1 instead of subtracting 1. And last but not least, that part is actually done. There is really no last but not least. I'm just saying a few things. So here we have it. So here's what's all that's going on. We have the boss, when it gets hit, the player bounces off of it. This is what these events do. And we're also subtracting the health and adding the speed. Now, one thing that you'll notice, we're going to have a problem that if we hit this boss, we're going to immediately have an issue. Well, first, let's see. We can use this up here as a test. We haven't made the alignment yet. But you see that as walking. But if I jump on the boss and attack it, first of all, we can't even attack it. We can't even attack the boss. We stand on the boss. So that's another issue in itself. Now, the reason why the boss isn't being bounced off of is that we set this as equal instead of a greater than. And that's an easy mistake to make. We just made it here. So when you set the greater than, let's see what goes on. So we jump on the boss, and you see we bounce off of it. And this guy went from walking to absolute stone cold. He just stopped moving. And the reason why that happened is that it got stuck in this hit receive animation, and it never changed. It just got stuck in that animation, and it never moved to a different animation. So now we want to actually move to a different, back to walk after it's done getting hit. So this is a very easy thing to do. Whenever you have an animation that you only want to play for a limited amount of time, this is what you're going to add. So let's add a new event up top, and let's add a new condition. First, we want to check if the animation of the boss is equal to hit receive. So we're going to type in if the animation by name of hit receive is even playing in the first place. But once this is finished, we want to check after that if it's finished. And if it's finished, we're going to change it back to walk. So we're going to add a condition. We're going to go into boss model, and we're going to check if the animation is finished. So we're going to type in finished, and then you'll see we have animation finished. And once it is finished, all we want to do is change the animation of boss back to walk. So we're going to copy and we're going to paste it. And we can look up top now, because remember, we don't have the boss aligned. You can see it's bopping up and down. That means it's walking. We jump on it. It gets hit for a split second, and then it goes back to walking. Like I said, the animation is very fast, so it's kind of hard to tell, but that's just the way that the animation looks. If you have your own animation, it'll look much better than that. But that's how you change it back to walk once you have the hit being received. So now we have the bounce logic, but now we want the player to also be able to die. So we're going to add a new condition and a new action. And we're going to do a similar thing of what we did with EBF. So we want to first check. We can actually just copy and paste all of this stuff except for the last thing. We're going to copy and paste it, but we're going to change the last part. It's just going to be in reversed. And instead of checking, of course, if it's greater than boss.object center z plus 20, we're going to check if it's less than or equal to. And instead of bouncing off, now the player will be set as dead. So you already know what we're going to do. We're going to set the variable value player dead to true. So we're going to go into other actions, change variable value, player dead, and we're going to set it equal to true. Now that we have that, there is only one more thing that we need to do for our boss. Besides the alignment, this is not the alignment part that we're dealing with, but we need to set some things for when the boss dies. We have to make the boss die. And when the boss dies, it needs to stop moving. It needs to stop moving. So, first of all, what will trigger the boss being dead? That's the first question. What will trigger the boss being dead? What triggers the boss being dead is that the boss's health needs to be less than or equal to 0. So we're going to do that. So we're going to add a condition. If the boss's health is less than or equal to 0, we're going to change the death of the boss to being equal to true. So we're going to click into our boss, and we're going to go access the variable health, object variable health, and we want to check if it's less than or equal to 0. And once we check this, we're going to add a trigger once, because we don't want to keep saying the variable boss dead to true, because that could lead to duplicate actions. So we're going to add an action, and now we want to check and make sure that the boss variable dead is true. So we're going to click into boss, we're going to type in variable, and we're going to change dead as equal to true. Now the rest of it is what happens when dead of the boss is equal to true. So we're going to actually copy this, paste it so we don't have to go through that again. Check if it's true. And if the dead variable of boss is true, what do we want to do? Now remember, we want to make it stop. And we have to make it stop because applying a force. Because just because we stop applying the force, it will just leave with the forces that it just had. It won't automatically get rid of them. It'll stop applying them in that direction, but it won't get rid of all of them. So we have to stop it manually ourselves. And stopping it is pretty easy. All we have to do is change the linear velocity of the boss. So we're going to click into the boss, and we're going to type in linear velocity on the X. And we're going to set that to 0. And you already know we're going to copy and paste this 2 times. And we're going to set the linear velocity on the Y and even the Z. The Z is not truly necessary, but I guess if it was in the air for some reason, that would be useful. So paste it 2 times, double click, and we're going to set the linear velocity Y as equal to 0. And we're also going to set linear velocity on Z as equal to 0. And now that we have this, we also want to set the animation of the boss to be equal to the death animation. So we're going to add an action, and we're going to go into our boss model, and we're going to go into animation, change it by name, and we're going to set it equal to death. And once we have this, we're also going to disable the mask, just like we did with our enemy. So we're going to add an action, go into our boss, and we're going to type in mask, and we're going to disable it. Once again, make sure to disable mask 5. Anything under won't work. So we're going to click into that and disable mask 5. Then we're going to wait 2 seconds, and then we're going to delete the boss and the boss model. So let's add an action, go to not variables, other actions, and let's go into timers and time, wait 2 seconds, and we're going to delete the boss, and we're going to delete the model. So we're going to click into boss, delete that, click OK, and we're going to copy and paste, and we're going to change this to boss model. And now that we have this should be a fully working boss if we didn't mess anything up. Besides that, now of course we haven't made the alignment yet. We're about to do that. It's pretty simple. So it gets hit once, it gets hit twice, it gets hit a third time, and it dies. And you see both of them get deleted. And the last thing we need to do here is do the boss model alignment. Now the last thing we need to do for the boss is make the model align with the actual boss object, and we're going to make the boss rotate towards the player, because we looked at the boss model right then and there. You'll see that's just facing forward, like looking into space, and we need it to face towards the player. And of course we're going to hide the boss object now since we have everything working. So we're going to put Shift A, and we're going to put all of this into one event, but it's going to be just actions. We don't need a condition here because we want these things to always apply. So let's change the center position of the boss model, and we've already did things similar earlier. So we're going to put center position, and for the X position, we're going to put boss dot center X. Put base boss dot center X, and we're going to use that center X. And you already know we're going to use boss dot center Y for the Y position. So boss dot center, and then we're going to put Y. Now that we have boss.center Y, we're going to click OK. And we also want to center it on the Z position. So we're going to add an action. And here we're going to put boss model is going to be equal to the center Z position. And it's going to be boss.center Z. put base again. It's all right. Boss.center Z, and we're going to autocomplete it. Once again, this is from my own testing. It depends on the model. It depends on how big your cube is. And we're going to put -40. This is for if you're using the models I have here. So we're going to click OK. And let's just preview it from here to see how it looks. Now, you won't be able to see it completely because the boss will probably be covering it up. But you see that the boss model is following us here. So that's a good thing. So also, we're going to make it always rotate towards the player. So I'm going to click into boss model, and we're going to type in rotate toward a position, or toward another object, not position, because we want to rotate towards the player. So the boss model is always going to rotate towards the player, and you'll see that you can have it rotate at a certain speed, but if you want to have it instantly rotate and always be facing it, you just use 0, and that's what we're going to do here. And last but not least, we want to just hide the boss. This is very easy. Click into the boss, type in hide, and then you can just hide the boss. So now we have boss model alignment that works properly. So we're looking at this guy, he's facing us, he's running towards us, we're running away because we're scared. And we jump on him. We jump on him again, and we jump on him again. He dies. And you see that he's still faced towards us when he's dead. And if you want to fix that, if like you could be lazy and keep this, but we're not lazy, so we're not doing this. All you have to do is make sure that the boss is alive in order for this to happen. So we're going to drag this into a separate event, and we're going to check if the boss dead is false. So we're checking if dead of the boss is false. And now we're going to preview. And now when the boss dies, it won't keep rotating towards us even though it's already dead, because it's still going to be able to move. So now that's dead, it won't rotate towards us anymore. And that's how you make the boss have model alignment with the player. And the last thing that we're going to do in this giant, massive tutorial, the last thing that we're going to do is add level select so that you can add several levels to your game and start making full 3D platformer games. Now it's finally time to add the level select to our game so we can make an infinite amount of levels with a saving and loading system. Now, basically what we're going to do is create a level select scene, and we're also going to have a level complete variable. And if you're going to have several levels, you're going to need several of these variables. But basically when you complete a level, it will save it. And based on whether or not that level complete value is true, you'll be able to go to the next level. And if it's not true, you won't be able to go to the next level. And since everything will be saved, this progress will be in between game sessions. So if you quit out, you'll still have all of your level progress together. So we're going to go ahead and do this. Now, before we create the level select scene itself, what we're going to do is create a new scene that is going to include something slightly different so we can tell that as another scene and not just level 1. So while we're here, we're going to go into the top left. And first of all, let's rename this to be level 1 instead of just untitled scene. I'm going to click back into it so we can see everything again. And all you have to do is right click this, and then you can duplicate the scene. And we're going to rename this one to level 2. Now what you want to do is go into level 2 and do something in your scene that makes it different from the other ones so that you know that you're not looking at the same scene. So in this scene, what we're going to do is just simply delete absolutely everything except for the ground itself, so we can tell that it's a different scene. And now that we have a second level, let's get into creating our level select scene. So what we're going to do is create a new scene from scratch. So let's go into our scene tab and add a scene. And of course, like we just said, this is going to be called level select. We're going to create this and then click into it. Now, since we're making a simple level select, we're not going to be making a bunch of fancy UI. We just want to know the actual logic behind a level select screen. All we're going to need on this scene in terms of objects is 2 buttons. So we're going to add an object, and this is simply going to be a button because there's presets for buttons. So you could use a regular sprite, but when you're using presets for buttons, it makes it easier to handle the clicking logic, especially for something like this, because if you're using custom fancy buttons, you would definitely want to use a sprite. But we're going to just use a small green button. And once we add this onto the scene, it's going to take a little bit of time to load, but it'll be loaded up. And all you have to do is double click into it, and you can change the object name. We're going to call this button 1. and the label is what the button is going to say. By default, it says button, but we're going to set this as just the number 1 so we can tell that this is level 1. Then we drag this onto the scene. So we have a button that has 1. And I'm going to simply change the size of this button just to make it kind of square. I like square buttons. And now I'm going to duplicate this, and we're going to move it to the side. Well, actually, we can't just simply duplicate it. That's on me. You can't simply duplicate it, and that's because we need a separate button object for button 2, because you can't duplicate it and then change the text. So we're going to duplicate this as in the object, and this will be button 2, and we want to double click into button 2 and change the label to 2. And that was no pun intended with the 2. So we're going to drag button 2 onto the scene, and we're going to just simply set them as the same size just for uniformity. So we're going to drag this, get rid of the ratio, and we're going to change the height to 131, just like the other one. I'm kind of precise. You don't have to do all of this while I'm doing right here, but we're just setting everything up to make sure that everything looks right. And now once you have 2 buttons, we're going to actually create a variable that handles this loading and saving. Now, what I mean, why do we need a variable? What we want to happen, I'm going to preview so I can explain this better. What we want to happen is that, of course, by default, you'll be able to click this because it's level 1. You don't ever want to be locked out of level 1. But by default, if you haven't beat level 1 yet, you're not supposed to be able to play level 2 because you haven't beat level 1. So what we want to do is that we're going to have a global variable, because this variable needs to be accessed between different scenes. So it's going to be a global variable. And then once we beat level 1, we're going to have a gem that we touch. We'll add that later. Once we beat level 1, we want to set that variable of level 1 complete as equal to true. And then we're going to save that value. And then we'll be able to go to the level select and play level 2. And so on and so forth. We can do this with an infinite amount of levels once you understand the system. So let's go into the top left and let's go ahead and add a global variable. And we have it right here. And we're going to add a variable. Now this global variable is going to be a Boolean because there's only going to be 2 values. And this first variable, and we're only going to create 1, but once you understand the concept, you get it. And you can just use this for however many you want. We're going to have level 1C, which stands for, well, level 1C, which stands for level 1 complete. By default, it's going to be equal to false. And now once we have that, we have the global variable, we're going to actually create the logic behind this. So let's go ahead and add an event. Now remember, we want level 1 to always be accessible. So when button 1 is clicked, we want to immediately load up level 1. So let's go ahead and do this. And this is very easy to do when you have button presets. All you have to do is click into a button. You can scroll down, check if it's clicked, click OK, and then add an action, and we're going to load up a scene. So we're going to change the scene, and this scene will be set to level 1. And now we have that. We don't have to make any conditions behind it because this will always be accessible. Now, when level 1 complete is set to false, we want to have a visual indicator that we can't even click into this button. So we're going to actually just change the opacity of the button. So let's add a condition, and we're going to go into other conditions, variables, and variable value. We have level 1C here, and we want to check if it's false. And if it's false, we want to change the opacity to 100. So let's add an action, and we're going to change the opacity of button 2, not button 1. We're going to change the opacity to 100. So now we have the opacity at 100. And if it's true, which means if we've completed level 1, then we want to change the opacity back to 255, which means that that's default opacity. So we're going to check if it's true, and we're going to change it to 255. And now that we have this, we have a visual indicator that we can't go into level 2. So once we load up the scene, you'll see that it's faded out, and we can't load up anything in it. But of course, we can't load anything, and that's because we haven't made any conditions for that. So the condition for us being able to load level 2 is that button 2 has to be clicked and level 1C has to be true. So this is going to be very easy to do. All we have to do is copy this and paste it. We want to check if button 1 Well, button 2 is clicked, not button 1. And we also want to check if level 1C is true. So you just copy and paste that. And if button 2 is clicked and level 1C is true, then you want to change the scene to level 2. So we can just simply edit this and put it at level 2. And one more thing, this is not going to be applicable right now because we actually don't even have the storage yet. But at the beginning of the scene, you'll want to immediately load up the variable, because normally when you save a variable in storage, and we're going to get to it later if you haven't did it before, but when you save a variable in storage, it won't immediately be just accessible again when you X out of the game. And actually, just so we can have a better understanding of that, we're not going to add that condition and the action yet. So we're going to go ahead and head into level 1. So when we get to level 1, of course, we need something, and I'm just going to delete the boss so we don't have to deal with them. But we need something that we can touch and it will actually make us complete our level. So let's go ahead and add a gem. And this is going to be not from the asset store, but this is going to be a simple 3D model. Once again, I'm going to head into my assets, and we're going to go ahead and add a gem to our game. And this is going to just be a simple gem. We don't need any behaviors or anything like that. And let's go ahead and name it. That's what we should do. Going to name it gem, and we're going to hit apply. Once again, we're on the 2D, so we're going to drag this onto the scene, head into our 3D view so we can reposition it. We're going to head back into our 3D view, and we're going to move around and change the position of our gem where we can actually touch it and it's not out of reach from the player. So now we have the gem right there. And once we have the gem, let's set up some events for when the gem is touched. So, of course, you already know the deal. We're going to create a new event group. This event group is going to be called level complete. This is going to handle all of the logic behind completing a level. And when it comes to the level complete, there's a few things that we want to have. Now, first, for level complete, we need the trigger for level complete. And the trigger is going to be if the player is in collision with the gem. So we're going to add a condition, and this is going to be if player is in collision. Now, since the gem is not a physics object, we're going to use the collision with the dotted cubes on the side. And the other object that we're going to check is, of course, going to be the gem. So if the player is in collision with the gem, there's a few things that we want to do. Now, the first thing that we want to do is make the player not able to move. Because if we were to touch the gem right now, the player will still be able to move. And we don't want that to happen because we don't want it to be able to fall off or something like that. It just looks bad. So let's go ahead and add an action, and we're going to click into our player. Now, the easiest way to make the player not move when you have behaviors like this that control the player, as you can see, we have no events that control the player's movement. So how are we going to make it not move? Well, all we have to do is deactivate a behavior. And what you want to do is type deactivate or d/activate, and you would think you might have to deactivate physics or something, but all you have to do is deactivate the 3D keyboard mapper. And the reason why you're deactivating this is because this controls what keys you use to move. If you don't have any keys to move, you can't move. So under activate, make sure it's no, and click OK. Now the player won't be able to move. Now the second thing you want to do is change level 1 complete as being equal to true. So we're going to add an action, go to other actions, variables, variable value, and we have level 1 complete. And we're going to change the value to true. Now once we have it as true, we will be able to go to level 2 if we kept playing the game. But if we closed out the game and went back in, our progress wouldn't be saved if we closed the game and went to level select. So we have to save this in the storage. So let's go ahead and add an action and go into other actions. Now, if I scroll down, you don't want to use save states. You want to use the default storage. Save states is better for saving the position of objects, not necessarily variables. Especially when it's simple like this, it's better just to use storage other than using save states, because save states will try to save absolutely everything. So let's go ahead and save a value, or not save a text. The storage name, you can have different types of storages. So the storage name is going to be simply levels, and the group is going to be 1. This doesn't even matter too much, but this just allows you to have separate types of storage. You can have groups inside of one storage and you can have different storages in general, like to make it more organized. And the expression is the value you're actually trying to save. So since we're trying to save level 1 complete, this is what you would type in the expression. It's simply going to be level 1C. That's what you're trying to save. So we're going to click OK. And now that we have this, we're going to simply just wait 2 seconds, and then we're going to change the scene to level select. So let's go ahead and add an action, and we're going to change the scene to level select. So let's go ahead and add, and we're going to go into scene, change the scene, level select. And of course we do want to wait 2 seconds in between, so let's add one more. And you already know how to get here by now, but other actions, wait 2 seconds. And then we're going to make sure we drag wait 2 seconds over the level select. Now before we preview, there's one thing that we're missing that we have to go back to. Go to your level select. And every time you open up level select, it should be loading up the levels. Because if you don't load it, even though the value is saved inside the storage, it has to load it to retrieve it in between game sessions. So what you want to do is very easy. Let's go ahead and add a new event. And at the beginning of the scene, we want to simply load the levels. So let's go ahead and add a condition. And the first condition will be at the beginning of the scene. So at the beginning of the scene, and that's the only condition we need, we're simply going to load everything. So go into other actions, we're going to type in load. And once we have load, there's going to be a few things. What you want to do is load a value. And it's going to ask you for your storage name. So that's important why you need to remember that. Remember we set our storage name to levels. And the group was 1. And the variable that we're trying to load, of course, is level 1 complete, or level 1C. And just make sure that you have this right, so we can go into level 1 events, and you can see that the storage is right and the group is right. So we can double check that, and now everything should be good. So let's go ahead and preview this. So we preview the game, and we walk into our gem, and the first thing that happens is we can't move anymore. And then it loads up the level select. And as you can see, our level select is no longer grayed. It's no longer grayed out. And we can click into level 2, and then it'll load up our level 2. And as you can see, there's nothing in here, so we know that's a completely different level. And just to make sure that the saving and loading is working, all we have to do is go into our level select and preview it. And you see that it won't be grayed out anymore. And that's because it loaded up the level again, so it knows that we've already beat level 1. So we don't have to do any recompletions of these levels. And that is how you do level select, and that also will bring us to the end of this giant, massive 3D platform tutorial. So of course, I want to thank you all for watching. I hope you all got something from the video, and make sure that if you have any questions, make sure to comment down below. I'll try to answer as many as possible, especially if it's within my time limits to answer even your technical problems in the comments. Also make sure to like, subscribe, and comment on the video. Also share it with other G developers so they can learn about this. It's one of the best tutorials we have on this topic right now. And also make sure to stay tuned for the next Q the Game Dev videos. We have Minecraft coming up. These are going to be giant hour-long tutorials. And we also have Genshin Impact coming up. But we will have some fillers in between that time. But make sure you stay tuned for Minecraft and Genshin Impact, because these will teach you extremely advanced GDevelop topics. So once again, I want to thank you all for watching, and I'll catch you in the next video. See ya.